Welcome to our channel. Here, we talk about technology, AI, gadgets, and digital life in a simple, clear, and real way.
Tech is changing fast, and every day there are new tools, new features, and new updates.
But there's one problem. We're all busy.
Most people don't have the time to understand everything in detail.
Blame Sheltan. I only share what's actually useful for you.
No drama, no hype.
Just straight talk. Let's get started.
Welcome to the Artificial Intelligence and Machine Learning tutorial, a full course brought to you by SmartFix Tech.
Hello everyone, welcome to the Artificial Intelligence course by SmartFix Tech. Recently, the AI industry's hit a big milestone with Chat 5. It's smarter than ever because it can now understand the context better, learn from few examples and help businesses solve the problems in new and creative ways. This shows how AI keeps evolving every single day and why knowing how to work with it is now more important than ever. In fact, according to the CNN, America alone is projected to need 5 million AI professionals by 2026 across sectors like healthcare, finance, manufacturing, and retail, with the roles like AI engineer, data scientist, and prompt engineer already paying salaries crossing 20 LPA per top talent. So the reality is simple: evolve or get left behind. Because here's the thing, most of the people use AI, but very few actually understands how it works and know how to build with it. And with the AI moving so fast, the job market has shifted too. Companies are now actively looking for people who can build, train, and customize AI for their specifications and need. But the supply for such talent is nowhere even close, and that gap is a skill gap. And that's where SmartFix Tech's Artificial Intelligence full course comes in to bridge that gap. Here, you won't just learn theory, but we will start from the basics, covering key parts like deep learning algorithms, including ANN, CNN, RNN, and transformers, as these are the building blocks of advanced AI models. You will also learn how AI actually understands the data, the main algorithms behind it, and how you can use them to start creating with generative AI. And by the end of this video, you won't just be using AI, you will be creating it. So let's get started without any further ado. Okay, the agenda is going to be very simple. First, importance of artificial intelligence. Very, very important. And the question should be, what is artificial intelligence, right? First, questioning is very, very important. We'll also talk about what constitutes, what makes intelligence. Okay, what is the difference between artificial intelligence, machine learning, and deep learning? I don't know how many times I've seen, including top CEOs, to some people make a lot of mistake while addressing where they mix up what is artificial intelligence, or they say AI is machine learning is deep learning is AI. They don't have the right way of answering what is what. We are going to clarify that also today. We are going to look at the basics of machine learning, which you guys have looked at in the past, but we are going to make our understanding very, very solid. So we are going to go a little bit more deeper into our knowledge of what machine learning is, and we are going to learn a little bit in depth, right? And then also a little bit on what are basics of deep learning. That is very, very critical. And once we analyze and understand all of this, then we jump into something more complicated like neural networks. So let me also give you an idea on what exactly are we going to do. We are also going to be writing a neural network from scratch. When I say scratch, we are not going to be using any library. We are going to be building a neural network from the very beginning so that you as students have a complete and absolute idea on how machine learning, or specifically deep learning based libraries or models, are working. What's the internal logic to that? Understood? Okay, everyone, let's get started with our understanding on what exactly is artificial intelligence. A lot of people do not have the definition absolutely correct, but we are going to talk about it a little bit in detail. See guys, artificial intelligence programs or AI systems are completely transforming the industry. Now, I think I can change the word by saying they have already completely transformed the industry. You look at the finance domain, right? I come from finance domain and I cannot tell you how many applications I have personally built that are being used by the banks, that are being used by the NBFC, that are being used by the systems across the world, right? Not just in America, but across the world, right? Be it the banking industry, the finance industry, the medical industry, the manufacturing industry, specifically with respect to the transport and logistics sector. Very recently, I was working with one of our clients here in Germany, and they are one of Europe's biggest logistics suppliers, right? And when I was having an interaction with them with respect to the small thing that they are building in a conference, of course, and they have been implementing AI all the way since 2016, 2017, and they have saved a lots and lots of money using artificial intelligence because AI has made their processes incredibly awesome. Now, back when I was in America, it was saving them money, because how American logistics works and how European logistics works is completely differently, right? Because the compliances in America are strong, but European compliances are stronger. So you have to kind of manage everything together. So be it your transportation, be it your logistics, be it your gaming, artificial intelligence has shown itself to be a very consistent and a very powerful tool. Very recently, everybody, Harvard University released a paper. It completely made everybody feel like, oh, what are you saying, right? Harvard University says using artificial intelligence in a company is going to give you 0% return on investment. Okay, the paper said that AI has no help or AI has no use if companies use them or if companies build anything in AI. It doesn't return or it doesn't give anything back to company in return. Everybody was shocked, right? Harvard University talking about this. But what they meant internally is, if you take artificial intelligence and apply within your company without clear goals, okay, if you do not have any clear goals, why are you implementing AI? What's the reason behind it? You just very simply blindly implement AI without any vision, and just because AI is cool, companies like that never saw any growth because they built the entire system wrong. So guys, I'm just simply trying to give you guys a small idea that artificial intelligence is not a silver bullet, okay? Don't think that artificial intelligence is this silver bullet that can solve every problem. It doesn't work like that. I always want you from today onwards, I always want you to question one thing. If you're solving a problem, any problem, in that problem, do you really require AI? Just because you're learning AI doesn't mean you have to use AI every single time. I mean, imagine, I'll give you a situation, okay? Your mom is cooking your favorite food, right? She cooks this hot meal, she gives it to you, she tells you, my child, have this. How are you liking it? You take one bite and say, Mama, I think this is missing. I think you should use AI. What's going to happen to you? Your mom is going to take that same slipper and she's going to make you taste everything, right? Point is, do not implement AI everywhere, right? This is the same situation happening in a country, in our businesses also. Not every single place AI is required. Question yourself and ask, is there an actual requirement of AI? Okay. So remember, AI, when or while AI has helped every single company make a lot of different change, make good money, save a lot of money, but in the same time, if it is not required, do not implement AI. Simple systems can be easy to implement, okay? But let's talk about what these ideas are. Yes, businesses are actually collapsing due to AI when they use them without any goals, because it is costing them so much more. Everyone, right in this particular class, you all must have implemented and or used ChatGPT based bots, right? Or your large language model based bots, right? Like the chat bots that can actually communicate with you, that can talk to you, right? You guys must have seen that, right? Now, did you know that back in America, right, there is a company, I'm not going to name the company, they also thought that, oh, you know what, let me be also cool. And by the way, they are America's one of the largest fintech companies. So they are not small company, right? They have a good $1 billion revenue and a $1 billion value, okay, valuation. What they did, they implemented a large language model based chatbot in their application. Did you know what people did with their bot? They started asking questions like, how do I make a pizza? And the bot responded with, okay, to make a pizza, you have to first take, and it responded to every single query. Now, let me ask you a question. Okay, if you are a finance application, do you need to respond to a customer's query about how to make a pizza? Or should you be responding to the query on anything else apart from financial related questions? No, they did that and everybody took a screenshot and put it on the Twitter. Okay, now what happens, okay, is people started asking questions like, what is a linked list? What is a Python injection or not the injection or inversion of control or dependency injection? People started asking complicated technical questions and they started getting the answer. So remember, if companies like these can make such mistakes, what about startups? Okay, so be very careful when you look at the implementations of AI, my people. It can also ruin your brand image. So you have to be very, very careful while implementing artificial intelligence. And guys, the reason I'm telling you both the good and the bad side of AI is because I want you guys to be aware that AI is a very powerful tool, but if you do not use it properly, it can also cause reputational damage to companies. And I have seen this happen in the past. So even though I want you guys to be absolutely comfortable and confident with the AI, with AI, I also want you guys to be aware that what can the disadvantages be, because I want you guys to eventually go back to the industry and work in the industry, right? You are not always going to be a student forever. Maybe by the next year, you guys are going to have a job of your own. You guys are going to be working in the industry. Having the right idea about what AI can do is absolutely critical. I cannot always give you guys the golden picture of what AI is always important, how it is amazing. It's not always true, okay? Companies have tasted the medicine of AI without understanding what the goal is, right? Use AI when it is required. A simple bullet point, right? Now, first of all, let's understand the definition of what artificial intelligence means. See, artificial artificial intelligence programs or AI systems are completely transforming the industry. Now, I think I can change the word by saying they have already completely transformed the industry. You look at the finance domain, right? I come from finance domain and I cannot tell you how many applications I have personally built that are being used by the banks, that are being used by the NBFC, that are being used by the systems across the world, right? Not just in America, but across the world, right? Be it the banking industry, the finance industry, the medical industry, the manufacturing industry, specifically with respect to the transport and logistics sector. Very recently, I was working with one of our clients here in Germany, and they are one of Europe's biggest logistics suppliers, right? And when I was having an interaction with them with respect to the small thing that they are building in a conference, of course, and they have been implementing AI all the way since 2016, 2017, and they have saved lots and lots of money using artificial intelligence because AI has made their processes incredibly awesome. Now, back when I was in America, it was saving them money because how American logistics works and how European logistics works is completely differently, right? Because the compliances in America are strong, but European compliances are stronger. So you have to kind of manage everything together. So be it your transportation, be it your logistics, be it your gaming, artificial intelligence has shown itself to be a very consistent and a very powerful tool. Very recently, everybody, Harvard University released a paper. It completely made everybody feel like, oh, what are you saying, right? Harvard University says using artificial intelligence in a company is going to give you 0% return on investment. Okay, the paper said that AI has no help or AI has no use if companies use them or if companies build anything in AI. It doesn't return or it doesn't give anything back to company in return. Everybody was shocked, right? Harvard University talking about this. But what they meant internally is if you take artificial intelligence and apply within your company without clear goals, okay, if you do not have any clear goals, why are you implementing AI? What's the reason behind it? You just very simply blindly implement AI without any vision, and just because AI is cool, companies like that never saw any.
If you build a large language model and if it responds in a non or a negative way about their, let's say, Marathi people, they have a certain, personalities who have come in the past, a certain other thing. Every single aspect of we got to be very careful with what answers it generates or what kind of answer it gives, right? Or either we can just completely take the LLM and solve the problem. So creating that also becomes very, very critical. Okay, depends on a very geopolitical situation, but I hope you got the logic, right? Okay, now everyone, over a period of time, right, artificial intelligence has grown in its adaptability. And when I say adaptability, is the amount of money generated by AI is crazy. Have you seen companies that were just started 5 years ago are now already at a 20 billion valuation, right? Facebook never became that rich within the next 10 years. Right? These AI companies have become so rich, so valuable to the company or to the world that they have literally grown 100 times in valuation, 200 times in valuation. I'm talking about Perplexity, right? Perplexity AI, which is a very simple AI tool, you can go to Perplexity and now you can connect your large language model to the internet. That's all it does. They have also released a new platform called Comet, which is an agent. Very simply put, you can ask a question, it'll connect you to the internet. But I mean, have a look at this, right? They built this, and now the company's valuation is in billions of dollars, right? Who's using it? How many people are using it? Let's talk about it later. But the adoption phase in AI is crazy. Okay, so this market is amazing. And let me also tell you something, guys. This is my own personal feedback because currently, okay, I live in Berlin, in Germany. And I always, whenever I have the time on Saturdays and Sundays, I always visit these startup, clubs and the startup ecosystem within the Germany's era, right? I mean, I see investors just handing 60,000 to 70,000 euros just like that to anybody who has an AI tool. If your tool is a simple tool or a complicated tool, does not matter. If it has AI, there are people here I have seen who are just ready to give you money to just start working on something related to AI. Now, this shocks and surprises me because I can see that investors are literally looking for the next big, application, the next Google or the next Meta everywhere, right? And they are all needing this tool, this platform that can be built on top of AI. And I see everyone is so adamant about investing money in an AI startup, meaning this is the right time if you guys want to build your startups, if you guys want to work in a company. If you're a fresher, none of that nonsense matters. Okay, be it whether you're a fresher or somebody who's with experience. If you are skilled, there are millions of opportunities out in the market. So many opportunities are available for you. I mean, it's crazy. It's crazy, literally crazy. If you're skilled in the field of AI, you have so many opportunities. The opportunities don't just stop. So you can always make an extra source of income using the power of AI. Okay, and a lot of people call it bubble, and I don't agree with that. And I'll tell you why I don't agree with the term bubble. Okay, see what happened now in the past we had something called as a website or the internet bubble, right? And the bubble burst because so many people kind of broke, so many companies came up, and then suddenly everything crashed. The dot-com crash of the United States happened. Now the reason I don't call AI as a bubble is because what happens is, unlike dot-com bubble, AI is actually helpful. Correct? You building a website for selling books online is or can be called as a bubble, but AI or your artificial intelligence system is actually helping you solve a problem. Okay, it's not a bubble. A bubble is something that can burst, meaning people who are thinking that AI is very powerful and suddenly every AI company in the world will just suddenly decrease in value. See, that's not something that's going to happen. Something else might happen. We call it as a market correction. That can happen, but I wouldn't call it as a bubble. Bubble basically collapses. Market correction just fixes itself. There's a difference, right? Yeah. So when a bubble bursts when there is no real value, AI is on it. Yeah, it's transformational. So market correction can happen, but it will not bubble. It's not bursting anything because we are already providing a value to it, right? They're just providing some values, just that the people will now have an option to choose a competitor over you, but the value is still going to be provided. So nothing to worry about. Okay, right. But one of the biggest advantage within artificial intelligence is what the definition of artificial intelligence versus machine learning. Everybody, this is where you guys have to be very critical with respect to how AI and machine learning can help you. Okay, be very careful and listen to me because what I'm about to tell you is going to make a lot of difference. Okay, everyone, can you read the definition of machine learning? Here it says machine learning is an approach to achieve artificial intelligence. It's a subset of artificial intelligence that aims to teach computers the ability to do task or perform task without explicit programming. It uses numerical and statistical approaches including ANN to encode learning with the models. Allow me to show you a diagram. Okay, imagine you have this large circle. Okay, and within this large circle, I call this large circle as, let's say, artificial intelligence. Your cars, your phones, your laptops, your ACs and whatnot, right? They are all intelligent, able to take their own decision. You have this large circle called artificial intelligence. Within this artificial intelligence circle, imagine you have this one more circle. Okay, and this circle, okay, I like to call this circle as, let's say, machine learning. Now, can you see that machine learning is a subset of AI? Meaning within the umbrella of AI, you have a small portion called machine learning, correct? You have a small portion, a small subset called machine learning. Now, you can ask me a question, sir, why is it a subset? What is the reason behind it? What's the intention behind it? See, the reason why we call this a subset is, my people, because what happens, machine learning algorithms or your machine learning models are like the small child, like a kid. Think of it like a kid. Okay, so everyone, imagine you have a child. Okay, this child does not know how to speak and is just learning how to have a conversation recently. So you have a fruit. Okay, you take a fruit. Let's call this fruit apple. Let's go to images, let's say fruit image. Let me copy this and let me paste it. Everybody, this right here is a fruit. If you're born in a Punjabi family, you're going to call it as a seb. If you're born in a German family, you're going to call it apfel. If you're born in a normal family where you call it apple, you're going to call it apple, right? Now tell me everybody, when you're teaching your son or your daughter how to name fruits, are you not basically going to give a label that you're telling your daughter or your son every time you look at something like this, call it seb, call it apfel, call it apple, whatever you want to call it, correct? So tell me everybody, if a child needs help like that, doesn't your machine learning model also need a help from you? I'll show you an example. Imagine you work or let's say you have a picture of a cat and you have a picture of a dog. Everybody, when I pass it multiple different pictures of the cat, don't I need to also pass a label called this is a cat, and for every picture of the dog, I need to pass a picture of the dog and also the label that this is a dog? Yes. So when my machine machine learning model looks at all the pictures of the cats and images of the dogs, will it learn how to distinguish a cat from a dog? Will it now know in the future how do cats look like and how do dogs look like? Correct or not? If you don't pass the label cat or dog, will you be able to make a prediction? If you pass it a picture, will you be able to get an answer from your machine learning model whether it's a cat or a dog? No, you're not going to get it because you never labeled. How are you expecting your answer to be labeled? So number one, please understand one thing, guys. Understand this very, very clearly. When your data is labeled, okay, when your data has labels inside it, such kind of machine learning model is called a supervised learning model. So what do you mean by that? If I have 100 pictures of an animal and another 100 pictures of an animal, to a computer, you need to tell that this animal is a cat and this animal is a dog. Only then the computer will be able to understand that, oh, I understand these 100 pictures are of a label cat and these 100 pictures are of a label dog. You can also give it the name, right? You can also say it hund, you can also say it key. Whatever language you work on, it doesn't matter. Label can change as per the language, as per your goal. But remember, labels are labels. Something that you're telling your model to look at. You pass it like a history, you pass it like a health. And that's why it's called supervised learning. Supervision is a little bit of help from a human being for telling it data, okay? For giving it the data which is labeled, because you want your machine learning to learn like a human being. Understand this. You are passing it information like a child, like a small kid, and you're explaining your kid, hey, look at this. This is what you call as a bird. Hey, look at this. This is what you call as a cat, and this is what you call as a dog, and this is what you call as a bear, right? You teach a child with many examples, helping the child make understanding of the real world with examples and labels. You pass the data in a labeled format to your machine learning model, and your machine learning model learns that, and that is what you call as supervised learning. Understood? Did you get the idea? Any machine learning system in the world is nothing but a simple algorithm that will look at the data, extract the pattern from the data. Simple as that. Did you get the logic until here? Did you get the idea until here? Look at this. Artificial intelligence has two different types of modeling. One is machine learning modeling, other is deep learning modeling. Everybody, within machine learning, did you know that there is one more bubble? This is a much more smaller bubble, and the name of this bubble is actually called deep learning. It's called deep learning, DL, deep learning. So what do you mean by deep learning? First of all, everybody, is deep learning nothing but a subset of machine learning? Can I say deep learning is a subset of machine learning itself? Within machine learning, you have something deep learning, or you have something called deep learning. Can you see it's not outside of machine learning? This is not a bubble outside here. It's something inside machine learning. So what do you mean by deep learning? Everyone, I'm going to give you an example, and I think this will make your understanding very, very clear. Guys, what happens is machine learning algorithms, right? Machine learning algorithms, they become intelligent because they use statistics plus, let's say, mathematics, okay? Math and stats together, when they combine together, they become very, very smart, right? We call them, they become intelligent by analyzing the pattern because they use statistics and mathematics, okay? Now, what happens in deep learning, okay? In deep learning, what happens? Preferably in deep learning, any kind of intelligence comes from what?
Labeling is performed for every single iteration, and this particular label that you see can be for each individual task, so you don't have to worry about that. So everyone, what do? We also need to understand that, sir, what happens if my data is not labeled? Then what do you do, guys? If your data is not labeled, then the kind of machine learning you learn or you implement is called unsupervised learning. What do you run? You run something called unsupervised learning. Now you can ask me a question. Sir, what do you mean by unsupervised learning and its difference? What is the difference in having unsupervised learning models and supervised learning models? I mean, there has to be one difference, right? Well, allow me to show you an example. See, guys, every unsupervised learning algorithm is a clustering algorithm, okay? Now, you must be wondering that what is this clustering, right? Clustering is nothing but forming a group, okay? Forming a group of sorts, or forming like a group is the right word. So let's just call it like a group. Now, sir, what does it mean? Imagine you're all working in a mall. Everybody, okay? You all work for a mall, okay? Let's say if your data has what amount of time the customers have spent in the mall, okay? What amount of time the customers spend in the mall, and what amount of money do people spend in the mall? Everybody, if you look at this data, do you see any label that this is a good customer, bad customer, terrible customer, don't give a customer? Do you have any kind of label like good customer? Suppose somebody has an X time Y money, X1 time Y1 money, X2 time Y2 money, ... Do I have a label here? Good customer, bad customer, worst customer, any kind of a label that my machine learning can model? What kind of labels, what kind of customers are absolutely? No, sir, I have no label. But everybody, there is no need to fear, because what unsupervised learning algorithms do is they create something called grouping. So don't worry, we will take two axes. One is called x-axis and the other is called y-axis, okay? On the x-axis, you plot the time spent by the customer, and on the y-axis, you plot the money spent by the customers. Are you going to get a graph which is going to be a scatter plot, everybody? Time and money, 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 right? I might get a data like this, right? I might get a data plot that looks like this, right? Now everybody, listen to me very carefully as a logical person, okay? As a logical person, as a person with simple plain logic, do you think there are 4 kind of customers in this graph? If you observe very carefully, the customers who spend more time in the mall, but they spend less money in the mall, can I say these are that customers? These are more time in the mall, less money in the mall. MTLM customers. Think of it like this: more time, less money spenders. Lovely. This is one of the kind of people that you see. The other kind of people that you will see is the worst kind of customers. Why worst? Because they don't even spend time, they don't even spend money, right? Less time, less money customers. LTLM customers. What are the other kind of customers that I see? Oh, I see there are other kind of customers who spend less time in the mall, but they spend more money in the mall. Can you see? And the other kind of customers that are exceptionally great is they spend more time in the mall also, and they spend more money also. So tell me everybody, did I provide a label by myself? Label did not exist. I created my own label depending on the data, and I solved my own problem. Correct or not? I looked at the data, I analyzed the data, and I created a label of my own. Now everybody, tell me, my question to you is very simple. Okay, sir, if I have a 2-dimensional data, which is how this data is, x and y-axis, no problem, sir. What if you have 50-dimension data? What will you do then? My people, do not worry at all, okay? How many groups? How many groups should I create? That idea is also automatically given by the algorithm itself. Are you understanding what I'm trying to say? If you're working with a high-dimensional data, how many groups are right amount of groups that you need to create, that idea is also given by the algorithm itself. And what kind of labels can you create? That idea you will automatically get when you look at the data itself. So don't worry, this is not a complicated thing that you will be doing. The more experience you get with the data, that's the value you get. And yes, that is right. That's what you call as the silhouette score, or you call that as an elbow plot, right? That's the value of the K that you calculate, right? Within the elbow plot, or your silhouette score, you calculate something called within cluster sum of squares, and within your silo score, you calculate something called the silo coefficient, which helps you identify what kind of value is optimal for your plot. Remember, elbow plot is also non-deterministic. Silhouette score is also non-deterministic. What it means, it only gives you a guess. It does not give you the perfect number, okay? So whenever you're performing something called as a clustering, okay, be it simple clustering or a complicated clustering or like a density-based clustering, remember, your Shillow score or your elbow plot or your detention score, these are all values that give you a prediction. It's a guess. It's not a guarantee. You need to go +1, -1, +2, -2 to check whether your values are correct. Don't worry, I'm going to explain it to you once I come to clustering. Explain it to you in detail, you will understand what I'm talking about. The idea will become absolutely clear.
Remember one thing, I personally say whoever has learned unsupervised learning problems or have solved at least 5 problems of unsupervised learning, according to me, is a king and a queen, because you have now solved the toughest part of machine learning. You do not need to worry about it. Everything is going to be sorted, and I'm going to show you some examples. Your life is going to be good, okay? I taught you what is supervised learning, I taught you what is unsupervised learning, but do you know what's the king or who's the king of machine learning? That is reinforcement learning. Your ChatGPT, your Claude, your Nano Banana, right? B-A-N-A-N-A, your Kimi, your Qwen, your DeepSeek. None of these models would have existed if you would not have learned or understood reinforcement learning. Reinforcement learning is like the final boss, the OG, the Pushpa of all the heroes, okay? The Iron Man of all the superheroes, the Marvel among all the, the fiction, let's say, your fiction or your comic world. And why reinforcement learning is important, okay, is because you gotta understand that reinforcement learning actually implements human-like learning in models, okay? Human-like learnings in model. Example, your self-driving cars, okay? No matter what everybody says, you can create a self-driving car with or without. Creating a self-driving car without reinforcement learning is impossible, okay? So let me explain what reinforcement learning is. Your idea is going to become very, very clear as to why reinforcement learning is apparently called as a king. I'm going to explain it to you, right? Look at 3 different situations. You have a self-driving car. This car is learning. It's learning how to drive itself, okay? This car is learning how to drive itself. What do you see? Do you see some kind of a trial and error method? Now, I will give you guys an example. You guys are going to listen to me, and you're going to understand how reinforcement learning works. Everybody, first of all, in order to understand reinforcement learning, okay, first I'm going to show you the example, and then everything will become absolutely clear, okay? In reinforcement learning, we learn by the method of trial and error and improve. Do you think this is how life works? You make a mistake and you improve, right? Do you make mistakes in life? Learn from the mistakes and move on? People don't learn from their mistake. The life keeps repeating the same mistakes. Until you learn from it, you cannot escape the loop. You take a small child, you the parents tell the child, do not touch this flame. The child is curious, touches the flame, receives the feedback, never touches the flame again. Now this is going to be very, very important. Why is this going to be important? Listen to me very carefully. If you want to build your own self-driving car, let me tell you how do you build it, okay? Let's say you want to build your own self-driving car. The first thing you need to tell the reinforcement learning model, who is your agent? I am not talking about Agent Vinod. I'm not talking about James Bond. I'm talking about who is going to learn. Who's the learner? The car is the learner. The car is learning how to drive itself. So who's your agent? Your car is your agent. Who has to make the decisions? Who is the one that is going to be responsible for making decisions? The car is going to be the one responsible. So what would you need to define? First, you need to define your car, or we call that particular thing called agent. So what is your agent? Car is your agent. Lovely. After you determine the car, you need to also determine something called environment, okay? Now what do you mean by environment? Guys, you want your car to learn how to drive itself on the actual road, right? Your surroundings will also be filled with pedestrians. Is it also going to have rainy condition, sunny condition, winter condition? Are you also going to have other car right next to you? Are you also going to have a traffic signal within the car? Is your car also going to learn how to drive itself in emergency situations? Suppose if there is an ambulance behind you, if there's a fire, truck behind you, are you going to train your car under conditions that are real life conditions, right? Are you going to guide the car in learning itself or driving itself in a
Error diagnosis and correction can be difficult. See, all these are fancy words of basically saying one thing.
When you implement machine learning model, just like how every pundit, every tarot card reader, every how do I call them, the people who look at your future, they tell you, right, whatever prediction I am making, it's not 100%. There is a chance I can be wrong. Just like you should not believe the astrological signs completely, you should also not be believing the machine learning completely. Remember, they are all good guesses, very good guesses. Sometimes it could be a very good, understanding of things, but understand that machine learning models have some limitations, and the limitations are they have a very huge data requirement. Okay, you cannot train your data on 5,000 people's data or 6,000 people's data and expect it to be a great model. Don't expect that. It is data hungry, requires a lot of instances, requires a good quality data. It does not, I don't know how can I explain lack of creativity, but it cannot create something it has not seen. There is nothing, it cannot build something that it has not observed in the last part. Okay, that's very important. Where to get such large data? Your company should already be having that right now. Whichever company you work for, your company already should be having this large amount of data. Not Kaggle. Kaggle is something that you should not be looking at. It's a platform to learn and to implement multiple different types of models. But that's not how your companies build models, or your companies does not create products that are coming from a Kaggle dataset. Your company should be keeping the data within themselves or buying from a third-party vendor. Anything can happen, but mostly what happens, companies' data are found internal to the company. So mostly you will find it on a Snowflake. Write an SQL query, get it from Snowflake, see how the data is, clear it, clean it, merge it, dump it, be done with it. Right? So there are many things that you can do in order to analyze what the model is doing and how it is working. And pretty much, that's how the whole logic works. Okay, now everyone, let's come to the most important point. Okay, and that point is, sir, if machine learning has some issues, then can we have something really, really critical? And the critical thing is called as deep learning. What does deep learning do, sir? How does deep learning solve my problem? How is deep learning the one that can help me analyze and solve these issues? So first of all, everybody, deep learning works completely differently from your machine learning models or your standard machine learning models. Deep learning works completely differently. So what do you mean by that? Now guys, why do we talk about deep learning and why is this important? See guys, deep learning models or deep learning methods, they use something called neural network architectures. Okay, and what you're able to see in front of you right now, these blue, orange and blue dots are an example of a multi-layered perceptron. Think of it like a neural network. Okay, and what are these neural networks? Answer, why do we call it deep? Right? See, the term deeps usually refers to the number of hidden layers in the neural network. So first of all, let's go back to the whiteboard and let's look at the architecture of a neural network. Okay, what and how do you build a neural network of your own choice? A neural network is divided in 3 different type of layers. Okay, you can say it is input layer, it is hidden layer, and it is output layer. Okay, you can first think of it like this. Your neural network is divided in input layer, hidden layer and output layer. Sir, what is an input layer? Input layer is a part where you let the data come or arrive within the neural network architecture. Think of it like a pipe. If you want to transfer, water or gas from one end to other end, you need to provide an outlet or inlet for the water to flow. And you need to provide an outlet for the data to flow outside. So you need to provide some place for the data to be enabled or to pass through within the model. So you first create something called as an input layer. Input layer is where the data first arrives. Then we have one more layer called as an output layer. Okay, the last layer is always called as an output layer. And in between, if you want to play around with your model, make it understand, then you can take multiple layers. Okay, and these layers are what you call as hidden layers. Okay, so your neural network is actually created of 3 different layer types: input layer, hidden layer and output layer. This is how you have created a neural network architecture. Now the question you can ask me is, sir, I understood all that. Okay, but Sir, how do I know for a fact that, my neural network architecture has some intelligence? I don't know what intelligence are you talking about, but what is this intelligence that you keep talking about? Is this intelligence, something, really critical, really important? Well, yes, it is. It's absolutely important. You guys need to understand that. What happens is, in a very simple sense, I'm going to give you an idea. Okay. Imagine you have a data in machine learning. Okay. Do you not break the data into different parts? Like, for example, think of it like this. Do you not say that the data is split into categories like your training model, or think of it like this, right? Let's say I have a data called age. Okay. Age of the customer. Okay, I have the age of the customer. I have let's say the age of the customer, let's say civil score of the customer. Okay, or I have the salary made by the customer. Okay, or the salary of the customer. And what is the target? My target is whether this person will be given a loan or not. My question is this: in this machine learning data, right? Can I say this part right here is what you call as, all of these are called as your features? Can I say these is what you call as your feature, and this right here is your target, right? These are your features and these are your target, right? And the loan, yes and no, that is a label. Loan is not a label. Yes, no, and maybe is a label. Loan is the target. Your yes, no, maybe, positive, negative, neutral, that is a label. Target is the loan. That's a different thing. Okay, good. Now everyone listen to me carefully. What did you understand here, or what did you get an idea from here? You got the idea that what happens. The idea here is very, very simple, and the idea here is this, right? Sir, I can split my machine learning data into two parts, my features and my targets. Okay, how many features do you have in this data? What kind of features do you see in your model? Do you see multiple different kind of features? Yes, you guys are able to see that. There are numerous kind of models that you see. Yeah, lovely. Now, sir, why do we say that these are different kind of features, specifically 3 different features? The reason why you're calling this as 3 different features is because so far in your data, you only have 3 features. That's why the number 3 comes up. So in a neural network, to take this particular data and understand from this, how many circles will you draw? How many circles will you draw? The circles also have to be 3, because in the first circle, which we call it as a node, okay, this circular thing that you're looking at right now, you call that as a node. In the first node, you will pass the customer's age data. Then in the second node, you're going to pass the customer's civil related data. And in the third node, you're going to pass the salary information of the data. Understood? Each individual node is going to only accept whatever feature you have in the data. If this is the model you want to train, you cannot take 4 layers and only pass 3 input. Your numbers of features are always going to be responsible for calculating how many number of nodes are you going to create. Did you understand? If you don't do that, there is no help that anybody can provide you. Your number of nodes and neurons are also supposed to be equal to the number of features within the data. Okay, lovely. Okay, sir, is everybody, can I highlight the input layer and make it, can I say that this is how should you take your input neurons? Lovely. Okay, sir, what about my output neurons? What about my output neurons? Sir, what about my output? How many labels do you have here? Do you have 3 labels? You have a yes label, you have a no label, and you have a maybe label, right? You have a yes, no, maybe. Okay, so tell me, do you think if you have 3 labels, your output neuron also will be 3 neurons? Okay, let me ask you a question. Very simple question. Sir, I have 3 labels, right? Typically, my output neuron is supposed to give my output for each individual class. The answer is yes. If the number of labels or your output labels are 3, then what do? The number of neurons you're going to take is also 3. Why? Because everyone, there is going to be a probability generated for each individual number. Like the first label yes is 90% probability, this is 0.5 and this is 0.5. Tell me everyone, which label has the highest probability? Suppose if the first label is a yes label, the second label is a no label, and the last label is a maybe label. So what is your model trying to tell you? Your model is trying to tell you that because I looked at your data, I received your data, your age is 23 years old, you make 780 civil score, your salary is also 3 lakh rupees, looks like this person will be given a low in the future. Is the probability for the label yes the highest, no is the least, and also the maybe is the least? Yes or no? So for whatever labels you take, are you going to generate probabilities for each individual part? Right. What do? You are going to make sure that every single time, this this is 0.05, not 5. It always has to match up to 100% or 1, you can think of it like this. So if you look at this data, right, there is 5%, 5% and 90%. So whatever your probability distribution is, whichever is the highest, that is the prediction for my label, or that is the prediction of my neural network. Understood the logic for your output layer? Your output layers also need to match up to the labels that you have put in the neural network. The most tricky part is working with the hidden layer. Okay, the hidden layer is where the trick actually begins with. If I write down a neural network's input layer and if I write down the neural network's output layer, will you be able to relate with why did I take 3 neurons in the input layer and 3 neurons in the output layer? The complexity or the issues arrive when you have to decide what layer makes my head ache. What layer makes my head becomes completely crazy, goes swollen? It's your hidden layer. Sir, why do you say that it is complicated? Because we have multiple choices. What do we have? We have multiple choices. Sir, what do you mean by multiple choices? Let me give you an idea. If you live in a place or if you go to shopping and if you go to the mall, you literally have 100 different variety of clothes available in the market. Do you suffer from a problem called choice problem? I have so many different
Simple as that, right? So tell me everyone, are we now taking the same information and now scrunching it down? I'm compressing it down and finally I get the output. Are you guys able to see the two different kind of neural network architecture? In my first hidden layer, I made my number of nodes bigger than the input nodes. And in the second type of neural network, I constricted or made my neural network node or hidden layer node smaller. So in this case, in the second neural network, I am performing something called data compression. First 3 people had the responsibility of creating a nuclear bomb. But in the next part, I made the responsibility to be given by only 2 people. And here I made the expansion available in a neural network by making sure that I expand it. Right? Now everybody, do you think in some cases you need to look at it in detail and in some cases you need to just let go and you need to do a quick check? Agree, disagree. For example, listen to me very carefully. If you are checking tickets of all the people on the railway station, is he going to check your Aadhaar card, your PAN card, your passport number, your information, where do you live? Is a ticket checker concerned about looking at your detail in such minute and absolute closer details? Nope, absolutely not. Hey, but what about visa or what about passports? Do they check your information a little bit more closely? Let's say a background verification protocol, right? You're joining a company and you want to do background verification. Do they check everything? Like, I'm sure if you guys know, in America, when they perform background verification, they even verify whether you have a criminal record or not. So tell me, are you not putting your effort depending on what kind of role and task you need to perform? So tell me, everybody, can I say a neural network that looks like this is also a valid neural network, 1, 2 and 1, and a neural network like this is also a valid neural network, 1, 2, 3, 4, 1, 2, 3, 1, 2 and 1? Can I say this neural network is also a valid neural network? This neural network is also a valid neural network. But sir, which one is giving you more accuracy or which one is giving you a better result? There is no other way better than trial and error. You implement this neural network also, you implement this neural network also. And depending on the type of data you have, try, is this one giving you a better answer or this one giving you a better answer? Are you understanding what I'm trying to say? Without trying this, without implementing it, do you think I have a magical method that I can just suddenly give you that will give you the answer even before you implement it? You will get the idea. How crazy is this statement? You want to know, sir, I want to get married to my girlfriend, or I want to get married to my boyfriend, but I want to know how will my marriage be. How can I tell you? You have to live in the marriage to realize what kind of marriage will you have. If you listen to any nonsensical advice online, you might not be able to live your life to the fullest, right? You got to live through the experience yourself to realize how the marriage would be. Nobody can predict it for you in the future, but you got to try things out and then see what you have to work. You got to experience that. If you have a neural network type 1, neural network type 2, you got to implement this and see which is better, or you got to implement this and see which is better and perform. Okay, if hidden layer 1 is 2 neuron and hidden layer 2 have 5 neuron, is it not everything is valid? If my input layer is like this, is my output layer, and your first hidden layer is a 2 small neuron and the third neuron is a 5 neuron, this is also valid. If you reverse the case, suppose if I take this neural network, okay, copy paste it for you here, okay, and if I flip the case right now, okay, what do I mean by flip the case? The flip case is I had first high number of neurons, then small neurons. Every case is valid. You just got to identify that the problem you're trying to solve or your problem statement, what neural network architecture
architecture is easy for you or what neural network architecture is giving you the high accuracy. You got to try everything. Understood? You just have to try for your data, for the complexity of your data, what kind of neural network architecture is important for you. Because everybody, my question is, don't you think everybody's problems are different in life, including neural networks? Your neural networks are receiving every kind of data in the planet, right? How and what kind of architecture is best for solving an image problem, for a text problem, number problem? Do you think depending on the data and the goal you have, the architecture also changes? If there are 15 people who need to live in a house, you cannot construct a 300 square meter house and expect everybody to live inside it. Your architecture is not sufficient to sustain 3,000 or 300 people or 30 people or 40 people. You got to ask and understand, did you guys get the understanding on why do you use a hidden layer to extract complicated patterns within the neural network architecture? And I also answered the question that you know what, you can have any kind of architecture in a neural network, a number or hidden layer, you simply have to try each and every one of them. And my people, let me ask you a question. Okay, let's say you all have become a data scientist and you have joined a company called Pushpa Enterprises. Okay, you are becoming or you've become a data scientist for Pushpa Enterprises, right? Lovely. Now within this Pushpa Enterprise, you have a data set size of 300 million records, okay, of customers, or 300 million data set size. The size of your data set, let's say 3 million, but 300 million is also large. Let's say 3 million, right, is the size of your customer query. Do you think you have the energy? Yes, records means rows, right? 3 million columns are not possible. 3 million rows, because let's say Google, how many people use email? Sure, there are more than 3 million people, but 3 million rows minimum, right? 3 million columns, it doesn't exist like that. Okay, listen everyone. Sir, am I going to try neural network architecture number 1 on 3 million data? Then I will try neural network architecture 2 on 3 million data. Then I will try neural network architecture 3 on 3 million data. Then I will try neural network architecture 4 on 3 million data. Do you think this is how machine learning is conducted or deep learning analysis is done? Do you guys think this is exactly how you're going to be solving the problem? You're going to take 3 million data set record and you're going to try neural network architecture 1 also, 2 also, 3 also, 4 also. If you do this, you know what they will give? They are finally going to give you the relieving letter. They are going to give you a relieving letter and they're going to be like, thank you so much for coming, but we don't need to see your face anymore. You know why? Because you just wasted and spent company's money like it's your own money. Okay? First, it took time and it is slow process. My people, if your data set size is 3 million records, why do you have to take all the 3 million? Because this is a population, you can always take a sample size of 10,000 also, right? And on a sample of 10,000, perform 100 different neural network architecture, nobody will stop you. The chances are, if the neural network architecture number 3 works good on sample, very high chances it will work on the entire data. Are you understanding what I'm trying to say? The reason is, sample is always representative of the population. Because the sample comes from the population, the behavior of the sample also will be of a population. If my dataset size is 3 million records, and if I have or randomly take out 10,000 samples, so can I say that this right here, this 10,000 right here, is what we call as a data sample. So can I say that my first hidden layer will be 3 neurons, my output layer will be 2 neurons? Can I say it like this? Can I say the first neural network architecture that I'm trying here is my first input layer is 3 neuron, my hidden layer is 2 neuron, and my first hidden layer is 5 neurons, 4 neurons, 3 neurons, and 2. Can I say it like this? This is the first architecture Shia built. The second architecture Shia is building, Shia tried this, Shia got a good result, no problem. Now what I'll do is, I will expand my neural networks layers. I will take 5, 4, 3, 5, 6. I'm going to try this also. Then Shia is going to try one more neural network architecture. What is that architecture? This time Shia will decrease the size of the neural networks layers. What he will do? He is going to take 9 neural networks layers, then 6, then 4, then 3, and then finally 2. So did Shia try 3 different type of neural network architectures on the sample? Yeah. Whichever neural network gave him a better result, what will he do? What is he going to do? Because he got the best accuracy at say model number 2, he is going to now add some more data to the sample of 10,000 to now make it 50,000. And once again validate that is number 3 still giving you consistent result? If in the second instance also you are getting a good result, then you can directly apply this neural network architecture to the entire 3 million records. They are completely in random. Not random, my dear, they are not random. You just have to try these values, you have to try multiple different types of permutation and combinations, and then they will, give you a certain result. Don't worry, I'm going to teach you how to do that. Add layers if your model underfit layers. Rather regularize the layers. Add model regularization, layer normalization, data normalization. Maybe don't remove the layers first, but maybe try to regularize them. Is it possible to observe how the intelligence is being built up? Do you know the scary part is? No, we don't know. We don't understand it yet. How neural networks' internal hidden layers are fired, and when I say fired, means they get activated and deactivated, and what causes the changes. Of course, we know how the weight values change. I'm going to explain what this particular thing is, right? But the problem here is to analyze how your neural network is giving a prediction. Well, that understanding is a little complicated and geometric in nature, meaning we nowadays have a new kind of modeling called XAI. Okay, it's written like this. XAI. The full form of XAI is explainable AI. What do you mean by explainable AI? If your neural network is a model that can take the user's patient's information and can make a prediction whether the patient can have a cancer or the patient does not have a cancer. Now everybody listen to me very carefully. Whether the price of a house will be high or low, is it causing a lot of damage to a human being's health? No. Whether the house of a price will be higher or lower, it's not causing any damage. No. But don't you think if you tell a patient you will have a cancer and you are wrong, do you think that that patient is going to be mentally distraught, destroyed from inside when you take away the will from somebody's life and say that you are not going to survive anymore, you're going to die? Do you think it's a great thing? No. So tell me everybody, when my neural network is a medical neural network, a neural network that makes the prediction that are you gonna live or are you gonna die, don't you want your neural network to tell you why did you predict the way you predicted? Why did I predict that he will die of a cancer and why did I predict no he will not die? Don't you want your neural network to tell you an explanation why did it do that? You want the explainability part of it? So remember, first of all, directly, is it possible to observe or understand what occurs inside the hidden layer? Directly? Absolutely not. Directly we don't, but what we can do is we can analyze their behavior. That behavior analysis is how we are able to understand the explainable AI. Understand, see, whatever happens inside the neural network's hidden layer, we call this model type as a black box. What do you mean?
But can I say person X picked up only one part and person Y picked up only one part? Did you get the logic? Both the people had a different kind of idea because the people who gave them the input gave a different kind of information. Can I say it like that? According to person X, he thinks that the event was very nice because the lighting of the event was good, right? And person Y thinks the event was very good because the food was very good. So can I say whatever related data you had about this, the information has changed according to that? So whatever information about the event you collected, you're able to now gather that information and put it up here. Did you get the idea until here? So now, my people, let's say you also have one more friend called Alpha. And now this person called X is also connected to Alpha and this person Y is also connected to Alpha. Now this person X in the Alpha is giving 50% information because X is connected to Alpha by 50% and Y is connected to Alpha by 90%. So can I say Alpha will also get the understanding of how the event actually went? Can I say that? The relationship mapping can be done like this. Alpha can also understand how the event went. And now Alpha, without even attending the event, has the relationship or the idea about what the event was, what the experiences was like, how you connected your input layer, your input friends to the hidden friends. Do you also have to connect the hidden friends to your final friend Alpha? You have to connect, no? X friend with the Alpha has only 50% of relationship with him and your Y friend is also connected to Alpha. But this time, Y is closer to Alpha and X is not closer to Alpha. But is X also providing information to Alpha? Y also providing information to Alpha? Both the friends are providing, however, informations are provided. But your Alpha will receive more information about the food than he will receive about the lighting of the event. Correct? So tell me, what will Alpha's final answer will be about the event? Alpha will say that, oh, the event had a great lighting, but I heard they had a much better food. Is this what his understanding will be? Because food is what shared was food was shared as a higher information than anything else. He knows about the event, he knows about the lighting, but he's giving more priority to the food, correct? You're getting what I'm trying to say? Everyone, did you guys get the idea on how the entire information flow from one state to other state? So this is how weights work in your data. This is how weights help you or weightage help you transfer information from one friend to other friend and other friends to other friends. Understood? This is how the flow of the information actually goes from one part to other part. Sir, how do we connect it with our example? 100% connection can be done. You know how? My people, my current input is hours of sleep, cups of coffee, and I have travel time. Agree? Disagree? Now, I want to make a prediction. And what is that prediction? I want to make a prediction that what is important and what will be my productivity score. Is my hours of sleep more important for productivity? Cups of coffee more important for productivity? Or travel time more important for productivity? I don't know. So my people, what I'm going to do? I'm going to assign the weightage for my first layer, 7, weight may be equal from alpha from x to y. It may be equal from x to y. They can be equal, unequal, they can be anything. Yes, my people? Do you know what do we do? Suppose this network or this layer 7 is connected to this neuron by a weightage of 0.9. This is connected by 0.3. This is connected by 0.1. This is connected by 0.2. This is connected by 1.3. And this is connected by 2.9. Have I given weightage to each individual layer and each individual connection? Am I passing information from layer number 1 to layer number 2? But I'm not just randomly passing every single output as it is. I'm providing a weightage in between, and depending on the weightage only, that much information is going to flow from one part to the other part. Because I hope you guys know one thing about information is not every information is useful, correct? Sir, how do we decide weights? How are weight values given called 0.9, 0.3, 0.1, 0.2? Initially, when the neural network is building, you decide to give the weight values completely randomly. You can literally take any random number, does not matter. Am I making myself clear? You can take any layer, any value, does not matter. You can initially take it in a completely random behavior. Okay? Hello everyone. IntelliPath offers executive postgraduate certification in data science and artificial intelligence in collaboration with iHub IIT Roorkee. Through this particular course, you'll get to learn multiple tools like Python, PySpark, SciPy, NumPy, Pandas, Matplotlib, TensorFlow, Git, etc. You are going to learn multiple skills like data science, natural language processing, deep learning, fundamentals of generative AI, application-based generative AI, as well as recent trends like agentic AI. This course is designed to get you ready for the AI world, so do check out link available in the description. Also, through this course, we have already helped thousands of learners take positive step in their career. You can check out their testimonials on our Achievers channel. In case in your life ever, you are going to find a data, and in this data you find a situation where you have a target variable or a feature with multiple different types of labels. For example, let's say you're trying to predict the house price, okay, the price of the house. And the labels that you're trying to predict are not just houses, but 500 different types of, let's say, 500 different types of, let's say, cities or city types, right? So here, what you have a column data where you have a feature and then you have a target, and your target has numerous instances or numerous, features, right? And within these, you have categories where you have 500 plus new values. Right? Now, of course, if you use something called one-hot encoding, you go crazy with a matrix size of 500 by 500 for just a column label like this. It will not work out for you, right? Now, if you ever find yourself in a situation like that, number one, go ahead with something called target encoding, okay? Directly. Now, why do we do target encoding, okay? See, target encoding is also called mean encoding. This is a very simple kind of encoding technique. What it does is, in target encoding, you take your data, okay, and you take all the average value in that particular range. For example, let's suppose you have values like Bangalore, Pune, other city X, other city Y. You replace it with the average value of the whole label or of the whole value. Right? What happens with the average value is basically you are trying to tell your model or teach your model the relationship of highness and lowness, meaning you're trying to teach the relationship of whether your neighborhoods with expensive houses will definitely get like a high value, cheap neighborhood would get a low value, and your model will learn the relationship between them, right? But the only problem is if you have only one house in like this rarest of the rare neighborhood and at like 8 million American rupees or 10 million American rupees, then the model might overfit.
So this you can fix using your cross-validation methods or maybe regularization. So target encoding is something that you can use as long as it does not have the rare edge case. You can fix it with target encoding. Sir, I don't want to fix it with target encoding. You can also use something called frequency encoding. Okay, what do you mean by frequency encoding? Is suppose if you have a city called Bangalore, how many times does the target Bangalore appears in your data set? The number of occurrence you have in your data. If you use that, you can always prefer using the frequency within it. Or also, you can pick up using something called mode. I don't say prefer using mode. Mode is not, mean, median and mode is not the right validator or the way you can identify as the right. Okay, I wouldn't say you can use mode directly. Frequency you can. Okay, so use the frequency of the number of occurrence for that particular value. For example, Bangalore has appeared 9,600 and 600 times, and let's say Pune has appeared like 7,600 times, and basically add your frequency as a part of your encoding for your machine learning to learn the relationship out of it. Okay, smaller the value, that's okay. Larger the value, that's also okay, because you use when frequency you use, or whenever you use frequency encoding, you convert your data into a type of frequency count, and your frequency count also correlates in a nice way, not the correlation that you're thinking. The correlation is correlation with respect to your actual data's behavior, the pattern, right? That's what we want the relation to have or exist, right? It is not random. It makes sense with respect to its pattern, and that is your encoding type whenever you're going to be using it within the model. So rather than going with something like this, either go with target encoding or frequency encoding. Try these. If these works out, you are going to have a good understanding. But also remember, if it is not this, then there is also something called binary encoding. In binary encoding, you are not going to convert everything into 500. Maybe you will have to convert something into 50 or not 50, 10 or 11 encoding. So either use binary encoding. You can also perform something called grouping. I don't think grouping also will help here, because 500 plus labels within your features, right, is not going to help you, especially if you do grouping. So try target encoding, try frequency encoding, try binary encoding. These three encodings are definitely going to help you, because what happens is with high capacity in the labels or multiple classes in the labels, okay, when your label is too wide and have a lot of varieties, usually people will go with either target encoding on a large basis. If it's even larger or even highly spread, then people usually go with frequency encoding. But they kind of have to, how do I say this? They kind of have to be very, very careful, because you no longer have the same older machine learning code. You just have to go beyond that, okay? Label encoding makes unintentional order. Yes, the order will not be the same. There is no ordinality part of it, right? Like for example, in statistics, we have ordinal data, right? Where the order makes more sense. Your frequency encoding will not give a single care about what your order is. Ordinality is not maintained. It's according to the data and its frequency. This is something that you have to look for. So now we will talk about something really, really important. I taught you guys a neural network example with the value of weights. I taught you guys an example that, hey, in neural networks, we basically take weight values, and these weight values are important for my model to perform, right? It's like a weightage I provide from person A to person B, connection, the data flow, how much of the data flow am I supposed to allow, okay? How did we decide the value of the weight values initially in any random, in any neural network? How do we define the value of the weights initially, everybody? We give them initial random weight value, correct? Lovely. Now everybody, I am interested in talking to you guys about something called activation functions, okay? What am I interested in talking about? I want to talk to you guys about something called activation functions. See guys, activation functions are used in machine learning only for one reason: to introduce non-linearity in your model, okay? In your model, let's say, okay, let me open up an example. Lovely. Let's say I have an example of this. Let's say vase. Yeah, let's call this as a metal surah, right?
Correct? Can I say it like this, and can I give it the values? This is W1, this is W2, this is W3, this is W4, this is W5, and this is W6. Can I say it like this? The weight 1 value, weight 2 value, weight 3 value, weight 4 value, weight 5 value. Okay, for now, everybody, for now, can I remove this second activation function right now? Because right now, I only am interested in teaching you the first hidden layer or neuron number 1 of the hidden layer number 1. Like, can I do this? So, W1, W3 and W5 is connecting from neurons of input layer to the hidden layer. Can I say it like this? Right? The first part is called as an activation or summation function, and the other is called activation function. Now, everyone, just for simplicity reason, can I say that the first layer or the first operation is summation operation? And once my model goes through something called summation operation, I get an answer called Z1. Okay, I get some number called Z1. Okay, I get some number. The number or the value is going to be called Z1, and the final answer from the neuron, okay, is going to be called as G1. Okay, this is going to be the answer. Now, everybody, let's randomly say that the value of weight 1, okay, is 0.1. Let's also give weight 3 also randomly 0.1, W5 also 0.1. They don't have to be same numbers. Understood, everybody? You can give different numbers also. This can be 0.1, this can be 0.6, this can be 0.9. You can give any random number. It's okay. Everybody, what do you mean by the concept of summation? My people, summation is nothing but Z1 is equal to you multiply weight 1 with the current input X. So here, this right here, this value here is called X1. This is called X2 and this value is called X3. So what do? You multiply W1 X1 plus W2 X2 plus W3, okay, X3. But sir, we have not written it like this. Let's write down the formula in a proper way. So first of all, we have W1 multiplied by X1. So this weight value will be multiplied with the input, correct? Right? This W1 will be multiplied with the X1. Then we don't have W2, but we have W3 multiplied with X2 plus W3 or W5 is multiplied with X3. Am I just basically performing addition operation, multiplication and addition? We can call this summation. Basically, the operation that I'm currently performing is a simple summation operation. Right? I'm not doing anything complicated. I'm not doing anything weird. I'm just pretty much summing everything together. I'm combining every single input into one single part. Lovely. Now, everybody, in every neural networks, we have something called weights, but we also have something called bias. Sir, what do you mean by bias? But why do we need summation? Okay, that's a good question. Do you remember in the beginning of the neural network class, I taught you a concept that you are basically allowing the flow of the information from one layer to other layer. So you have to sum everything because you want the input of all the neurons plus the weight multiplied together to pass through neuron number 1. Summation basically clubs the data together and passes it on to the next layer. Understood? So you just have to take everyone's input, multiply them with their weight values and allow them to pass together. That's a very, very important step. Without this, your neural networks will not perform or your intelligence in the model will not perform. Yeah? So taking it, passing it or taking it, summing it and adding everything together and passing it to the next layer, that's what we are basically doing. Right? Okay. Lovely. Now, everyone, even after you have weight values and all of this, sometimes your neural network can go in a direction where it is not supposed to go. Right? You're trying very, very hard to make the neural network go in the right direction. But sometimes, okay, I'll give you an example. Imagine you and your best friend, whoever your best friend is. I'm assuming everybody has a best friend here, right? Somebody who you can always, I wouldn't say rely on, but you can insult, you can hate, somebody who's gonna go rob a bank with you, right? Somebody who will, jump 5,000 feet for you. I'm sure that kind of friend, right? Same, bad mouths. So let's say you and your best friend have gone to a lake. Okay, you guys are chilling in the lake, and in this beautiful lake, your friend is on a boat. Okay, this is the boat on which your friend is sitting. You, because you have a phobia or fear of water, you are sitting at the at the edge of the lake. But on the edge of the lake, you have a lot of stones. Smaller stones. Now, see, I do not appreciate violence. I do not want you to hit your best friends with stones, but for example purposes, for teaching you neural network example. Okay, just giving a simple idea or example. I do not absolutely appreciate you hit your best friend with stones. Hypothetical, of course. Right? Hypothetical. Never want to give you guys any idea for violence. Now, let's say you want to, hit this piece of stone to your friend, or you want to hit this small piece of pebble, something that will not hurt him or her. Let's say you first throw a stone and the stone falls here. My people, this is where your friend actually is, and this was your prediction where your friend could be. Did you make a mistake in calculating the difference between actual and predicted value? Correct? So once you know you have made a mistake, once you realize you have made a mistake, will you not get a feedback that, oh, no, the mistake you need to do is not correct. So next time what you will do, you will throw your stone very closer to your actual data. First, you are very far away from the actual data. Then you are very close to the actual data. Correct? And then you realize that, oh, I'm very, very close, just that my energy towards the left hand side needs to be a little lesser. And in the third attempt, you will actually hit your friend's boat. So tell me everyone, whatever real data that we have 85 and the mistake that we did 17, from that we will only calculate the mistake or the error, because this error will help my neural network learn that brother or sister or my dear friend, the actual value is supposed to be 85 and you are way far away from 85 to something called 17.478. Can you please fix yourself? And then my neural network fixes itself. Understood? So tell me, the mistake that my neural network did is actually not a bad thing. It's a great thing, because based on this mistake, I will be able to fix myself. The larger the mistake, the more fixes I perform. The smaller the mistake, the smaller fixes I perform. Is the logic clear to everybody? I only wanted to explain the logic, right? So everyone, what can I say my error is or mistake performed by the model? How do we calculate the mistake performed by the model? Can I say predicted minus actual or actual minus predicted, whatever you want to take? Guys, so for example, if I say actual data, ACTUAL, minus predicted data, who can tell me what is the difference? My actual data is 85, my actual value in the data is 85, but I am getting something called 17.478. If I subtract them together, what is the overall mistake that my model did or it failed to realize? 67.52 units worth of data or worth of understanding in my model. Agree everybody? This is the error right now. Everyone listen to me. In every neural network, for a neural network to be called a neural network, it needs to do two operations: forward propagation plus backward propagation.
Did we complete forward propagation right now by making the first prediction called ypred equals to 17.47? A first forward propagation is done, right everyone? A forward propagation is done. Now we need to go back, right? Now we need to go back and see things, right? So everyone, listen to me very carefully. Sir, first of all, after forward propagation, after forward propagation, what do we need to do? We want to update our weights and biases, right? Can I say we want to weight or update our weights and biases? Sir, how long do you want to update your weights and biases? Until the error or until the mistakes made by the model. Between who? Between the actual data and predicted data. Or predicted value is as minimum as possible. Can I say this statement is making a lot of sense? This statement makes a lot of sense. The idea of performing back propagation after forward propagation is only one thing. We want to update our weights and biases value in such a way that the error between our actual data and the predicted data is as much as possible. Yes? And it is a derivative part, right? We don't perform actual derivation. We perform something called partial derivation. And there is a reason, a very important reason behind it. Let me tell you something. Your best friend will lie to you. Your wife can lie to you. Your husband can lie to you. Your government can lie to you. But mathematics can never lie to you. You know why? Because mathematics is the only universal rule or universal law on this world or entire universe. The math that works, let's say here, works everywhere else. So the only thing consistent and in this world is mathematics. Math is the language of the universe. And sir, why is math so important? Is because whenever you think about calculating derivative between certain things, the law of derivation of derivatives will make a lot of sense. Because the law of derivation or derivatives, simply put, derivations will not directly apply here. Because you have to implement something called chain rule. I'm going to tell you what chain rule is and then we will follow that. But the idea here is that, sir, we need to perform some derivation of some sorts. Why do we need to perform derivation? I need to come to that in a second. I will come to that. So everybody, we are going to now perform something called back propagation. Back propagation. This right here, from now on, whatever I'm going to write is going to be a step for performing something called back propagation. So everybody, this is the neural network that we had. Let me copy this all the way from here to all the way from here. Copy this and paste. This right here is the neural network that we have built, where we have the input layer, we have the hidden layer, and we have the output layer. And then we finally had the ypred value, right? Is my understanding correct? Right? But our example needs forward propagation. Okay, now everybody, can I say that when you calculated the vibrate value, because of the vibrate value, I was actually able to calculate my cost? Whatever cost is, no, what I'm saying is our value is 17 and we have to reach at 85. Still we need forward prop. So you keep doing forward propagation again and again, right? We keep performing forward propagation again and again multiple times. Forward, backward, forward, backward, forward, backward. We keep going back, we keep coming front. We keep going back, we keep coming front. Let's suppose if you're working for a hotel and lot of people, review your hotel or your restaurant. Some people say positive stuff about your restaurant. Some people say negative about stuff about your restaurants, and some people say neutral stuff about your restaurant. Okay, now tell me, can I say this is a label that people give me in a review? Some people have a positive things to say, some people have negative things to say, and some people have neutral things to say. See, the labels in my model or my machine learning model is positive label, negative label, and neutral label. Now tell me, can I perform binary classification here? No, you cannot perform binary classification. Okay, what if the label was only positive and negative? Then would I have been able to perform binary classification? Yes. Lovely. Okay, but are we doing any classification modeling? Are we performing any classification related task? No. What are we performing? Are we performing regression based task? Yeah, lovely. Now, let's come and look at the neural network. If we were to perform any classification based task, then here, towards the output layer, we could have used sigmoid activation function or softmax activation function. But since we are performing linear regression, number one, we do not need to pass an activation function. We just need to combine everything and let the data pass directly. No need of any activation function. You take activation functions towards the output layer only and only if you are performing multi-label classification or multi-class classification. Point number one is this. The second reason that we are also not taking okay, let me write down the big condition. If I was showing you an example of classification, even then I would not have taken it directly because for now it's a simple neural network. Okay, the neural network performance that I'm doing right now, it is a simple neural network, right? So because if you are building like one simple hidden layer, very minimal neurons, just teaching something for an example, you can also to an extent avoid it. But remember, in real life cases, you of course need to add an activation function to the output layer also. And in the hands-on classes, I will teach you. You will know exactly how I'm adding activation towards the end also. I will teach you that in real life. But remember, because of the example that we are learning, we don't do it. Can we do it? Yes, 100%. Yeah? Okay. Now, I was saying that my vibrate was calculated in the forward propagation. And because of my vibrate, I was actually able to calculate something called y actual minus y predicted. Correct? And my people, can I also say I'm taking something called whole square or vibrate minus y actual? Whatever you guys want to consider, y actual minus y pred. Vibrate minus y actual. The order will not matter because you have studied something similar called mean square error. Correct? In your linear regression, when we square the error, they all become positive and they avoid negative and they avoid cancelling with each other. Right, my people? In machine learning, do you know what do we call this as? We call this as a cost function. What do we call this, everyone? We call this as a cost function or we call this as our loss function. Understood? You can call this as your cost function. You can call this as your loss function. It won't make much of a difference since the definition here is very, very bleak. Okay? Call it cost, call it loss, up to you. Nobody is stopping you. So everyone, listen to me very carefully and look at the relationship between them. Who is connected to what? Let me give you an example. When you guys were young and something in your house was broken, would you say and point fingers that I broke it because he pushed me? And then your elder brother will be like, I was running because Didi asked me to run. So do you point your fingers making an entire chain who's responsible? Do you remember you did that thing in your childhood where you pointed fingers, the other person pointed fingers somewhere else, and then the other person pointed fingers somewhere else and all of this happened? We will apply the same logic into the same analysis. You know why? Because everyone, tell me, whatever high error I got or the cost function I got, can I say cost function will point the finger and say that I got the higher value because you gave me a certain vibrate value, that's why my value is lower and higher? Can I say cost function will point the finger to vibrate and vibrate will say, Arey yabul answer because the W7 value that you have given me is this much. Now everybody, very closely I want you to listen to me. Okay? Very closely I want you to listen to me because if you don't listen to me now, whatever I teach you is pretty much as good as as not teaching you anything. Everyone, the reason my Vipred answer came up is divided into my Vipred was calculated with the help of W7 also, G1 also, W8 also, and G2 also. Were all these four things responsible for calculating, including the bias, responsible for giving me the value of Vipred, right? But do you know in mathematics, we have this amazing technique called partial derivatives, okay? Everyone, we call them partial derivatives. My people, what this derivative do is, I want you to imagine G1 like this circular button, W7 as a circular button, G2 as a circular button, and W8 as a circular button, and B2 as a circular button, okay? Think like a radio, your old radio, your grandfather's old transistor radio, okay my people? You keep every single value of your father's or your grandfather's transistor button as 0, but you want to calculate one thing, and that is only and only W7. How much change did my W7 make in my entire VIP or my output? Only W7, how much is it responsible for my entire cost value to go wrong? So tell me everyone, in the initial stages, isn't this what I'm going to check? That Vipred is saying that I'm responsible or my responsibility falls on W7 because the value of W7 was this much. Can I check how much W7 value, which was 7, caused a change in my Vipred, and because of this I got a change in my error? Can I go back like that? Is it possible to go back like that? Yes, it is very much possible. It's not at all difficult, right? Okay, how much problem did W7 cause because of this W7? I got Vipred. I'll give you an example, okay? Listen to me very carefully, okay? I'm sure you guys know that American police, I'm not sure if you know this or not, but I mean American police is according to me the best police, right? Like I've lived half across the world, everywhere, but nothing beats the American police system, right? Now, let's say my people, there has been a, let's say, how do you call this in English? A riot. Okay, a riot in your area. Everyone listen to me. There has been a riot in your area. Okay, there are 3 people whose name keep coming up in the riot. Okay, now tell me, everyone, let's say person number 1 is P1, person number 2 is P2, and person number 3 is P3. Police definite riot, danga fasad, right? Marpeat, riots. You just call them riots, right people? Police knows that there were 3 people who caused the riot together. The riots were caused by these 3 people. But what if police wants to identify only and only person 1? How much was person 1 responsible for the riot? Person 1 was 80% responsible for the riot. Person 2, 10% responsible, and person 3, 10% responsible. Who will they catch and give a good biryani to? Who will they give better biryani to? Person 1, person 2, or person 3? Who will they, sit and speak, talk nicely with all the respect and love? Who will they love enough? P1, P2, P3, P1, right? Tell me one thing. Of course, they will pick up all 3. Of course, P1, P2 and P3. They all will get a good dinner and a breakfast from police. But the point is, who is causing more problem, more issues? Is it P1? Okay, so tell me, just like the same example here, right? Imagine your neural network police wants to know that my error is becoming so terrible, so bad, that my bigger answer or the answer is so different from the actual data. So won't the police first identify how much of the mistake is happening from W7? How much percentage of the mistake just W7 brought into my model? Then later I will check for W8. Then I will check for G1. You getting the idea, right? Everybody got the logical idea? Now, why am I first only checking W7? Because how much W7's value made my mistake in my cost function bigger. Only that I'm checking. Sensitivity. Think of it like that. So everyone, how do we perform sensitive calculations? We perform it like this, okay? We perform something called partial derivatives. Sir, how do we perform partial derivatives?
We have not. Yeah, exactly. So can I say that directly from G1, I actually need to go to Z1, and then via Z1, we need to go to W1. We cannot go directly from G1 to W1 directly. We need to do it like this. This is the relationship. Can I say it like this? That del G1 divided by del W1 can be written like this. First, G1 is responsible with Z1, and then dZ1 is responsible with W1. Can I say this is the replacement formula? I need to add it in my original formula. My G1 with respect to Z1 and my Z1 with respect to W1, right? So if I replace this formula, my final formula will look like this. So del cost by del Vipred, my del Vipred, okay, with respect to my del G1 into my del G is causing my changes in the del Z1, and the dZ1 is happening because of dW1. Can I say this is the entire formula? Making sure consistently we talk about the logic behind it. Sir, del cost by del Vipred, we already know the answer, no? When we do differentiation or partial derivation, we already get the answer, no? 2 into Vipred minus Y actual, correct?
Correct or not? This right here, the partial differentiation of this is going to give me this, right? Yes, backpropagation is of course a little complicated, but if you go through it logic by logic, then this math formula will start making sense. What is my Viprate formula? My Viprate formula is this. What is the Viprate formula? I'm going to copy this, everyone. This is my Viprate formula, right? I can copy this and paste it, copy this, and absolutely towards the end, paste it here. Lovely. VR equals to this one, okay? This right here is my Vipred. Let me write it like this. Let me remove this and let me add Vipred equals to this. Now, everybody listen to me in the second part of the equation. Deal with them separately, okay? See, deal this equation separately, this equation separately, this equation separately, and this equation separately, okay? Think of it like an individual way of solving, okay? This part I've already solved it. So this is already done. Multiplied by del Vipred with respect to G1, with respect to G1, okay? With respect to G1, I have to calculate. So tell me, everyone, which piece of the equation here mentions G1? Does this mention G1? No. Does this mention G1? No. Does this mention G1? Yes. G1 with G1 is 1. So the overall answer is W7. So can I say that the answer here is W7? This part of the equation is solved. Let me ask you guys a question. Sir, my G1 is nothing but 1 by 1 plus e to the power of minus x. Isn't this what my sigmoid function is? And this entire equation is what I'm calling G1, correct? Now my people, when you actually do this, you are actually writing it like this, minus of Z1, correct? Rather than calling it X, you're calling it Z1, correct? Like this is the actual formula that we are using. Now see everyone, the partial differentiation of del G1 by dZ1 is slightly tricky math, okay? It takes 6-7 extra steps of math, which is not something that I think I should be teaching you guys or you should be learning, because that math is going to go deeper, and frankly, you don't need to go that deep. So for your understanding, just letting you know that if you calculate the derivation of del G1 by dZ1, your answer will be G1 multiplied by 1 minus G1. Okay, just know this is the answer that you got or you get. We apply something called substitution method substitution method within calculus to solve the problem. We substitute 1 plus e to the power of minus of z1 as x, and we deal it like 1x, and then pretty much we go ahead and do that. So it's like a whole different ballpark game, and it's like a different thing. So you don't need to get into that. So just understand that if you do del G1 by dZ1, you're going to get this answer multiplied by everyone. What is Z1 value? Can I say Z1 value is this? Let me copy this. Let me copy the whole Z1 value from here till here. Go here and paste it. This is my Z1 value. Now I'm taking Z1 with respect to what? Everybody, this Z1 is calculated with respect to what? Del Z1 by dW1, correct? So tell me, is this part of the equation has W1? No. This part of the equation has W1? No. Does this part of the equation has W1? No. Does this part have W1? Yes. W1 with W1 itself will be 1. So the answer will be X1. So can I say this part of the equation we got X1? Were you able to solve this complicated part of the neural network also? It became easy. My people, what if I tell you the knowledge that you have gained in the theory classes is enough for you to write your first neural network, and that too using Scratch or just from scratch? No library, no TensorFlow, no PyTorch, no scikit-learn, only NumPy. Just with NumPy, we will build our first neural network from scratch. Let's actually go ahead and do that, everybody. So tell me this. How do we do this? How do we solve it? Neural networks using NumPy. Okay, this is how we will write it. We will say that we are building neural networks using NumPy. This is what we are trying to do. Everybody, in case if I want to start anything from the beginning, here's what I'm going to do. I had entire data, right? In my file, I have taken the entire data from the beginning, right? Can you see? Can you look and observe only the first row of the data right now? Just the first row, 7, 8, 2, 8, 25. This is what I have used in my math, correct? Right? My 7, 8, 2, 8, 25. This is my math, right? So what am I going to do? Import NumPy as NP, correct? I'm going to say that my training data is np.array, and inside this array, 7, 2, 8, 25. Can I say it like this? And actual data is 85, correct? My training data is 7, 2, 8, 25, and my actual data is 85. For now, only focus that SQL, if you learn, it will be very, very helpful. Okay, think of it like that. Okay, now W1, W2 is equal to, okay, W3, W4 is equal to W5, W6 is equal to W7, A, W8 is equal to, and B1, comma B2, comma B3 is equal to. Tell me, have I taken all the weights and all the biases? Yeah, B3, right? Sorry. Okay, so what value did I take of W1? I don't even remember. Let me just go ahead and check it. What value of W1 did we take? I think some random value we took. Is it W1 0.1? Okay, so basically 0.1 this many time, right? So W1 0.1, okay, now, comma, W2, W4, W6, W2 0.16, 0.166, W4 0.5, okay, I'm going in, this is 0.66, and I think this I remember. I think I remember giving something about 7 and 3, right? If my understanding is correct, I think I remember giving, 7 and 3. Lovely. Okay, not bad. And this bias 2, bias 3 is -4, -4 and 12. -4, -4 and 12. So -4, -4 and 12. Have I taken my weights and biases also? Generally, how are weights and bias assigned? Are they assigned randomly? The answer is yes. In a neural network, in the beginning, your weights are first assigned randomly. You don't do anything. They are assigned randomly and you got to work on it randomly. Correct? Yes. Lovely. So now tell me this, right? We have taken a function called sigmoid, and inside this sigmoid I take a value called x. Can I say return 1 by 1 plus e to the power of minus x? So I will say e np.exp to the power of minus x. Now everyone listen to me. Going to close this and I'm going to close this. Can you guys tell me what this function does? Is it going to take the value and it will do 1 by 1 plus e to the power of minus x, the formula of G1 that I have taught you? So tell me, have I taken this formula called sigmoid? Yeah. So define, right? Forward propagation. Okay, propagation, forward propagation. I want to calculate the value of Z1 and I need to calculate the value of Z2. Correct? Then you need to calculate the value of G1 and then you need to calculate the value of G2. Is my understanding correct? So first of all, what is the formula of Z1? Come over here. W1x1, W3x2, W5x3 plus B1. Correct? W1x1, W3x2, W5x3 plus B1. That is the formula. Can I write it like this? Can I say W1 multiplied by, open the bracket, close the bracket, W1 into my input array, 0th index, which is the first value, plus W3x2, which is going to be a copy here and a paste here, and an x of 1. So this is going to be W3x2 plus W5, this plus B1. Is this the value of Z1, everyone? W1x1, W3x2, W5x3 plus B1. I'm going to copy the same thing for Z1 and I'm going to paste this for Z2. But here W1 becomes W2, W3 becomes W4, W5 becomes W6 and B1 becomes B2. Is my understanding correct? Simple. Whatever the value of Z1 is, do I pass it through something called sigmoid and it becomes G1? Same thing happens with Z2. I pass it through something called sigmoid, it becomes G2. So if I pass Z1 through sigmoid, it becomes G1. If I pass G through sigmoid, it becomes G2. Finally, I get one final answer called ypred. What is the formula of ypred? W7G1, W8G2 plus B3, correct? W7G1 plus W8G2 plus B3. So can I go ahead and say return? Return, what do I return, everyone? I will return everything. I will return Z1 also, Z2 also, G1 also, G2 also, and finally what do I return? My ypred. Can I say these are all the values I will return from my function, from my code? And run this function. If I perform the activation function, if I perform the forward propagation in front of you, see Z1, Z2, Z2, G1, G2, ypred equals to forward propagation of the value x. Printf double quote of Z1 value is this, which is Z1, Control Z, Command Z, and here it will be Z1. Copy the whole thing. Paste it here, Z2 is Z2, paste here, G1 is G1, copy this, paste this, G2 is G2, and finally my ypred is going to be equal to my ypred. And print double quote /n, error is,
printf double quote of cost function.
Oh, by the way, you also need to import Keras here, okay? Because all you have done is currently only imported layers. You can also do it like this from TensorFlow, import Keras, right? Just write it like this. Run this, okay? And call this here keras.input. Now inside this input, I'm going to say shape equals to, I'm going to say 3. Please tell me, what does this mean? How many neurons am I taking at the input part? And am I telling my machine learning program that you are the input layer by mentioning the name of the method called .input? Am I telling the neural network that you are a part of the input layer called .input? Correct. We have written the input fa. Of course, my input is done. Now what do? I take another value. You have an input layer that you wrote, and you have this hidden layer that you wrote. Now your confusion will be, okay, sir, if you look at this particular code called layers.dense, dense, correct? I have taken my input layer and I'm taking my hidden layer, right? And from this hidden layer, what do you see? Do you see something called layers.dense? Right? You see something called layers.dense, my people. I have taken an input layer, okay, in my neural network, in the input neural network of my TensorFlow, 1, 2, and 3, and then I have taken my hidden layer. Okay, first of all, how many hidden layer do I have right now? Can I say only one? Hidden layer 1. Sir, what do you mean by this word called dense? My people, the connection that we have completed with our neural network, isn't this a fully connected layer? Haven't we connected each neuron with the other neuron? It's a complete neuron-on-neuron connection. We call this fully connected layer. This is what we call as a dense connection. What do we call this? What do we call this? Dense. So am I taking my input layer, am I taking my hidden layer, and I'm connecting them together with something called dense? Can you see .dense? And how many neurons am I taking in that one layer? In that one layer, how many do we take? 2. And what is the activation function am I passing it with? Is this also how we built our neural network? Correct. Now everybody, I have connected my input layer and I have connected my hidden layer. Correct. But the problem is, I am not sending the data from my input layer to my hidden layer, or we are not passing the data. So to pass them together, to connect them together, you need to write a bracket and connect your input like this. Now did you connect them? Now is the connection created? We are passing the input to the hidden, and now the connection is all linked. Bluetooth device is ready to pair. Right now, your connections from your input to the hidden layer are done. Now, how do we go about it? We have to write down another output layer. Now, how do we write down our output layer? Outputs equals to, again, layers.dense, and please tell me what neuron or how many neurons I had towards the output. Can I say 1? Can I say activation? Because there is no activation, will I just let it pass the way it is? Linear activation. No activation at all. Whatever is the input, let it pass. And did I connect my hidden layer with my output layer with something called X? Did I connect my input to my hidden and my hidden to my output? Now tell me, everybody, linear activation. Whatever is passed, let it pass. It's linear. There is nothing called no activation, is basically no activation. Think of it like this. It doesn't have anything there. You cannot keep it empty, unfortunately. Got it until here? Did you get it? I have no activation. Think of it like that. My activation function does not exist. I cannot pass anything linear. Whatever comes, let it pass, okay? And what I'm going to do, I'm going to return something called model, and I'm going to run this. Now, before I print or return the model, I have no model to print, because the problem is you need to combine these three together also. You know, everybody, in a neural network philosophy, you got to combine everything together. So you got to take it like this. Model is equal to keras.model, okay? You're going to take keras.mod, and inside the model, your inputs are equal to inputs, okay? Your inputs are equal to your inputs of the neuron, comma, your outputs are equal to outputs. Can you see in the output we've connected X here and pass X here also? So these two are connected, and anyways, these two are connected. So basically, we've connected all three of them.
In any neural network that you write, hidden layer, input layer, they're usually not supposed to be announced. You don't do that. It's just supposed to behave or be and not worry about anything. Okay, why two-time input and output and model lines? Good question. Is this the code that I have written? I wrote down a variable called inputs. Is this my variable called inputs? Everyone, this variable is taking how many neuron as an input? So 1, 2, and 3. And what is the name of this layer? The name of the layer is called inputs, correct? Because you have mentioned that this is the input layer, correct? Dot input. Now, how did I name my output layer? Sorry, my hidden layer. The name of my hidden layer is called by the name X, and I'm doing something called layers.dense. How many neurons are seen in my hidden layer? Neuron number 1, neuron number 2. What do you mean by dense? Connect this input to this input. Connect this input to this input. Connect this input to this input. Then connect this input to this input. Then connect this input to this input. Understood? Dense come connect everything together. Full connections, complete connections of my layers. And what activation function am I passing between them? Sigmoid. Sigmoid activation equals to sigmoid. Now, to allow the data to flow from input layer to the hidden layer, the data should be allowed to pass. Permission should be given. So did I take this input and pass it here, connecting the layers completely? Layer number 1, complete. Layer number 2, complete. What about the third layer? Do we have the one and final layer called my output layer? And what is the name of my variable? Outputs. What is the name of my variable? Outputs. And how many neurons do you have in your layer? 1. Very, very good. Is this a dense connection? Meaning you need to connect here to here, and you need to connect from here to here, correct? Right. And the activation is linear, so whatever input you do, no activation, it will allow the data to pass as it is, correct? Because we are performing regression. Lovely. And what else do? We take the input, X, and we connect the hidden layer with my output layer. And now the data will start flowing from my hidden layer to the output layer, correct? My hidden layer and my output layer are all combined together, correct? Okay. Now, my people, you have given names to each individual layers, correct? But did you give a common name to the entire model? The whole model combined together? Have you provided a name to the model itself? You did not. How do you provide one single name for every layer in the neural network code? You do that using something called .model, where you combine your inputs as inputs, you combine your outputs as outputs. My people, what is the name of my input layer? Is it inputs? What is the name of my output layer? Is it outputs? So am I saying that the inputs to my model is the name of a variable called inputs, and the outputs to my model is the name of a variable called output? This way, I'm combining everything and making it into one final model. Correct. So I don't need to address the neural network as input separately, X separately, output separately, but one single name called model. Hello, everyone. Intellipath offers executive postgraduate certification in data science and artificial intelligence in collaboration with iHub, IIAT, RKI. Through this particular course, you'll get to learn multiple tools like Python, PSpark, SciPy, NumPy, Pandas, Matplotlib, TensorFlow, Git, etc. You are going to learn multiple skills like data science, natural language processing, deep learning, fundamentals of generative AI, prompt engineering, and application-based generative AI, as well as recent trends like agentic AI. This course is designed to get you ready for the AI world, so do check out link available in the description. Also, through this course, we have already helped thousands of learners take positive step in their career. You can check out their testimonials on our Achievers channel. We created random data for hours of sleep, cups of coffee, travel time, and my Y data is going to be nothing but the sample size, which is going to be a number between 0 to 100. This is the data, and this is my neural network. And here I am calling the function. Why am I calling the function? Because in Python, you have to call a function, correct? If you do not call a function, will it work? If you do not call a function, will it work? It does not work, everybody. Once you call this function with a variable called model, everyone remember, every neural network that you are going to build in your future, you have to perform some operations like compile operation. Sir, what is a compile operation? Compile operation is the added feature of your neural network. What will your neural network do? Example, model.compile. Let me zoom into this, right? Model compile, what are you going to do in the model? What optimizer, okay, will your neural network use? Your neural network will use an optimizer called keras.optimizer, okay, Atom. So everyone, see what we are going to do is, most of the times we prefer using an optimizer which is generic and has very good functionality and convergence properties like Atom. Okay, Atom is a good optimizer, like how you have been using your gradient descent, your RMS prop, multiple different type of optimizers. Preferably, you can use something called Atom.
It's impossible. Now do one thing. Can we take a hybrid approach, mix of both? The neural network program that you just ran right now, okay, is not good, is absolutely not good, sir. If you write a code like that, you will be, I don't know, I mean, if I was your colleague, then I would definitely, I don't know, yeah, I mean, I would find you in the middle of the road, I would put a towel on your head and, I would go to town on you, right? Like, if you wrote a neural network code like that, I would be very, very furious because, yeah, I mean, that is not how you're supposed to write a neural network code. So what do we do, sir? You have to write a code in a very nice way, right? In a way which could be understood by me in a much more simpler way, right? I'll be able to understand it in a way where it becomes very, very simple for me to work on it. So let's actually write it down in a nicer way. How do we do that, right? How do we perform that operation? See everybody, if you want to perform that operation, okay, we got to understand, okay, what are we dealing with? Right? Like, what kind of problem statements are we dealing with? Are we dealing with a classification problem? Are we dealing with a regression problem? What kind of data am I dealing with? Depending on that, I'll be able to make my judgment that, okay, you know what? I need to do this, I need to do that. And what kind of work do I need to, perform? Like, what kind of tasks do you think I need to perform? Okay, so see what I'm going to do now. Let's take a classification problem. Let's take a classification problem. What is that classification problem, right? Imagine you have multiple different classes, right? Multiple different, let's say, instances within the class. How do we actually work on that? So, like, what do we do, right? For example, how do we fix that? Right? So first of all, let's do this. Let's analyze, sir, if I were to work on some, let's say, production heavy software, or let's say, sir, I am supposed to work on this particular application where I'm supposed to, give you an idea about whether that particular, value or this particular instance is giving me, let's say, correct answers for my classification or not. Right? I have multiple different classes and I want to identify which one is good and which one is bad. And how many classes am I able to predict correctly or not? So I want all of that, right? I want better understanding for all of this. And how do I go about it, right? How do I fix that? See, number one idea that you need to get right here, right? Now is this, sir. Let's, what do we do? Right. Okay, what was that data? I don't remember. There are multiple different data sets that I use. Is this deprecated or not? I think that's deprecated, right? Let's see if I am... It's impossible. Now do one thing. Can we take a hybrid approach, mix of both? The neural network program that you just ran right now, okay, is not good. is absolutely not good, sir. If you write a code like that, you will be, I don't know. I mean, if I was your colleague, then I would definitely, I don't know. Yeah, man, I would find you in the middle of the road. I would put a towel on your head and, I would go to town on you. Right? Like if you wrote a neural network code like that, I would be very, very furious because, that is not how you are supposed to write a neural network code. So what do we do, sir? You have to write a code in a very nice way, right? In a way which could be understood by me in a much more simpler way, right? I'll be able to understand it in a way where it becomes very, very simple for me to work on it. So let's actually write it down in a nicer way. How do we do that? Right? How do we perform that operation? See, everybody, if you want to perform that operation, okay, we got to understand, okay, what are we dealing with? Right? Like, what kind of problem statements are we dealing with? Are we dealing with a classification problem? Are we dealing with a regression problem? What kind of data am I dealing with? Depending on that, I'll be able to make my judgment that, okay, you know what, I need to do this, I need to do that, and what kind of work do I need to, perform? Like, what kind of tasks do you think I need to perform? Okay, so see what I'm going to do now. Let's take a classification problem. What is that classification problem? Right? Imagine you have multiple different classes, right? Multiple different, let's say, instances within the class. How do we actually work on that? So, like, what do we do, right? For example, how do we fix that, right? So first of all, let's do this. Let's analyze, sir, if I were to work on some, let's say, production heavy software, or let's say, sir, I'm supposed to work on this particular application where I'm supposed to, give you an idea about whether that particular, value or this particular instance is giving me, let's say, correct answers for my classification or not. Right? I have multiple different classes and I want to identify which one is good and which one is bad. And how many classes am I able to predict correctly or not? So I want all of that, right? I want better understanding for all of this. And how do I go about it, right? How do I fix that? See, number one idea that you need to get right here, right? Now is this, sir. Let's, what do we do? Right. What was that data? I don't remember. There are multiple different data sets that I use. Is this deprecated or not? I think that's deprecated, right? Let's see if I am. Do you get what you want from me? मतलब अगर आप मुझसे ये पूछें कि आपको मुझसे क्या चाहिए, तो मैं क्या जवाब दूं? Can you refer to me as government servant or an employee or a part-time employee or a consultant or a volunteer? And can you also detail about my work so that I know what your data type is? Then I'll be able to directly give you the answer. And please tell me your phone number so that I can directly give you the answer in a.
When you guys were taught a concept of linear regression, did they teach you something called variance inflation factor? VIF, or variance inflation factor, is used to check for multi-collinearity. Correct, you were taught what is multi-collinearity. How is multi-collinearity bad? How do we make sure that multi-collinearity doesn't exist? Example, right? If you have two features, feature A and feature B, and they are very, very highly correlated with each other, that means I can drop feature A or B and I can only use A, or I can drop A and I can only use B. Any one I can use. Correct. Using both of that will be a problem, right? Using both of them will be a terrible option because you're basically passing in an introduction to your model that can make your model just not very accurate. So tell me, everyone, my question to you is this. Right, let us move this one a little to the left. Yeah, so my question is df.columns, okay? How many columns do you see in this data? Right, apart from churn, how many columns do you see? So many columns, right? approximately up to 20 more columns including churn. Now the problem is, as a data scientist, what algorithm or technique is good to identify which column will be important for my model? Isn't that amazing, everyone? Which feature do I need to choose in order to make sure my prediction is accurate as possible? Correct, because in the future, as a data scientist, you may not know every column's understanding, correct? Whether every column is important, which column is what, and what is their importance, you may not really know. So, do you guys know if you are ever in a problem like this, what can you do? We are going to perform something called feature selection technique. What do we call this? We call this as feature selection technique. There are so many different types of feature selection techniques available in the market. Among them, one of the famous one is called RFE. The name is called recursive, okay? Recursive feature elimination. We call this recursive feature elimination. There is also something called directive feature elimination. There are multiple other variants of it. Recursive feature elimination is the quickest, but more generic in nature. So, sir, what will recursive feature elimination do? Recursive feature elimination will help you perform feature selection faster, okay? So if I take my variable like this, numerical features, okay? Numerical features is equal to, my people, can I take until here, till here, all the way from here till here? Copy and paste. Are these all the features that I want to include in my analysis? Yeah, customer ID is a terrible feature. No, it's not even a feature, right? I can remove customer ID, right? Customer ID does not give me any advantage. I hope you guys understand why. Because customer ID called 101, 102, 103, does this make any help? Does it give any help? No. So tell me, are these all the features that I'm going to use in my model and I'm going to identify which one is important? Correct. Yes. Is my understanding correct, everyone? Now tell me, everyone, whenever you perform recursive feature elimination, is it a good idea to include your target also in this? Don't do that. If you do it, you will get 100% correlation, correct? Are you not going to get a 100% correlation from your mapping with respect to your target, which is anyways the terrible answer, right? Okay, so in here, did I remove my target? My target does not exist because that would be terrible. Correct. Okay, now everyone, what did I do? I have taken all my features that I want to test which feature is important. Now everyone, to convert or to use my features, I need to convert my categorical features into, numeric features. You guys understand what is numeric, categorical to numeric, right? For example, if you look at this data, df.info, can you see no, yes should become 0, 1, yes and no should become 0, 1, electronic check, mail check should become 0, 1. You're getting what I'm trying to say now. Whatever categorical variable you have in the actual form, you want to convert this into numerical form. So what I'm going to do is, for column in numerical features, I'm looping through each individual feature. If df of column, if that column data type, .dtype is what? Is let's do it like this, equal to object. Let's do it like this. Then I will say that for that particular column, what am I going to do? I'm going to do pd.factorize, and I am going to convert that column, into my numerical representation. Now everyone, let me ask you a question. Do you know what is method called factorize? What does factorize do? pd.factorize, are you able to see a data like this? If you have a variable called BBA, CBA, how many alphabets do you see here? Unique alphabets. Can I say 3? A, B, C? Did it convert that into its own individual label? 0, 0, 1, 2, 0? Have a look at this. B, none, ACB. Did you make your none -1, but every other variable proper numerical format? Were you able to convert your labels or your categories into numbers 0, 1, and 2? Basically label encoding them. Am I making myself absolutely clear? So pd.factorize is basically label encoding my data. Was I able to perform this? Yes, it is mapping it directly based on the column level. This is important because my computers do not understand object data. Correct. Because my computers do not understand object, I have converted the object into what? Into what? Into its individual encoded format. Now everyone, to combine everything in one single place, to combine everything, right, combine all, how do I do that? Can I say numerical features is equal to f in numerical features if f in df.columns? Everyone, please tell me if this code is making sense. This is a simple list comprehension function. Correct. To make sure all these numerical features are a part of one individual list or one individual, let's say, list or array. If I print my numerical features once again for you, is everything available as one single list? See, I have combined everything together. F for f in numerical features if f in df.columns. Is this like a double check whether all my features are in one single place or not? Check. See, even if you don't use it, it's okay. It's not going to cause any problem. Now everyone, tell me this. What will be my training data? df of all the numerical features will be my training data. And what will be my target data? df of churn. Did I split my data into x and y? Yeah, the reason why we use 0 is for indexing, my dear, because factorize, doesn't it give you like this, two nested lists? So 0 means the actual direct value, so it returns array of an array. 0 means I get the array, the main single array, where 0, 1, 2, 3, 4, 5 are written. That's why we do this. Yeah. Okay, my people, everyone, the method that I'm teaching you right now is called recursive feature elimination. Okay, recursive feature elimination. C is a technique in machine learning where which variable is important, okay, which feature is important for my model, I'm able to check it. See, my people, your recursive feature elimination will not work, cannot work, without a baseline algorithm first. If you want to perform recursive feature elimination, you have got to use some already existing library. Example, sir, if I perform recursive feature elimination, what do? You need to go back to the beginning of the program. Why do we need to go back to the beginning of the program? Because have I imported some libraries here? Yeah, you can also do direct conversion. Okay, now everyone, listen to me here. What I'm going to do now, I'm going to import NumPy as NP. I'm also going to import matplotlib.pyplot plt. I'm also going to import Seaborn also. No, you know what? It's okay. Let's not do cond. It's okay. From sklearn.modelSelection, okay, let's import train test split. Okay, this is something I might use. I also need to perform something called model pre-processing. So you know what? Let me also import standard scalar, something I will use in the future for sure. Now from sklearn. I am going to actually call it as a feature selection part. Correct, yes, import recursive feature elimination. Lovely. And from sklearn, the baseline algorithm that I'm going to use for recursive feature elimination, let's use something called random forest. That's a much better. Yeah, I think we can actually, you know what? Let's also do one thing. sklearn, why is it not fulfilling? Yeah, from sklearn.metrics, import accuracy score. Let's also print accuracy score and classification report. Am I missing anything? I think you can also take confusion matrix, right? F1 score. Let's not. Yeah, it's okay. Let's not get an F1 score. It's okay. I think this is enough. If I miss anything, I will come back once again, no problem. Okay, everyone, look at this. Did I import all the necessary packages in my variable? Yes, of course. Now I'm going to run my model. So see guys, to perform recursive feature,
If hyperparameter tuning does not want to be achieved, can I create some default neural network that will always run no hyperparameter performance, just some default model I have written? Correct. Can I say it like that? Yes. Can I have this basic simple neural network every single time I don't want to perform hyperparameter tuning? I can do this. So can I say model is equal to, let's write down the basic model. Model is equal to models dot. Now everyone, this is one of the bigger problems you're going to find. Did we implement or call anything from TensorFlow so far? Any TensorFlow related operations that we have done? No. What are we going to do? Import TensorFlow as TF. Okay. From TensorFlow, okay. From TensorFlow.keras, import something called as layers, and we are going to import something called models. And what are we going to do? Import, let's also call something called as Keras tuner. Okay. If you don't have Keras tuner, let me do one thing. Keras tuner, give me one and let's see if we can install it. Okay, copy this, paste it here, run it. Keras underscore tuner as KT. Okay, you're going to call the control Z, Keras tuner also, and let me also import tuner is done. Yeah, I think these three are done. Okay, lovely. Now, perfect. See, this is what I wanted. Everyone listen to me. What I am basically doing, okay, because this is my default neural network, can I take it like that? Layers dot dense, I'm going to take something called 64, comma activation is equal to ReLU. My input shape, or let me come over here and say input shape is equal to, I'm going to take a bracket here and I'm going to say xtrain dot shape of 1, and I'm going to pass in the variable comma here, which is the actual input variable. I'm going to take something called, maybe I don't know, let's try something called layers.dense. Inside this, let's say 32. Let's say activation is equal to ReLU. Okay, let's take a comma here also. Let's say layers dense. What do? We give it 16? No, let's give it 8 now. Let's not write too much. Activation is equal to ReLU. I think we can do that. And finally, I can perform layers dot and I can write 1, and activation will be equal to sigmoid, since we are performing something called as binary classification. Okay, and once you are done with this piece of code, I can just write down something called model.compile, and inside the compile part, my optimizer is always going to be equal to your Adam. I will come over here and I will say my loss, since this is a binary classification, this is binary cross entropy, something that is very critical, and matrix is equal to ACC. When you see this piece of code, okay, sigmoid can handle up to 2, so we are writing 1, but if you had say 4 classes, then can you use something called sigmoid? Can sigmoid handle more than 2 classes, class labels? Which one will you use here? You will use softmax, and if you use softmax, then the number of nodes should be equal to the number of class labels. If it's binary class, use sigmoid. If it's more than 2 class, use softmax. Up to 2, more than 2. Why did we write it like this? The reason we wrote it like this is because in case if you want to build a complicated neural network, always write it layers dot, not input, not hidden, not output. Don't write it like that. Is how you write a basic neural network, but not your complicated ones. Is the idea absolutely clear? So for input layers, no need. Layers, yes, that is automatically yes. Can you see here this piece of the code automatically adds that? No need to take it as a separate method. If you want to pass learning rate here, we can also pass absolutely. Okay, so how do we class C Adam optimizer? Okay, Keras, so how do we add optimizer like Adam? We do it like this. Can you see Keras.optimizers dot? And inside this I can pass something called learning rate. Let's write it like this. From TensorFlow.keras.optimizers import, what am I importing everyone? What am I going to import? I'm going to import something called Adam, okay, which is your Keras.optimizers. So I can even go ahead and directly import something called Adam here. Okay, ADAM Adam. Now what you can do now, you can pass the optimizer like this, Adam, and inside this you can pass learning rate is equal to 0.01. What we are going to do now is we're going to write down a code that performs hyperparameter optimization. How do we perform hyperparameter optimization? We perform it like this. Model is equal to models.sequential. Can I say this is an important step, everybody? I will perform models.sequential. Okay, my first hidden layer, my people model.add layers.dense, units is equal to units 1. Let's say actually, let's take it like this. Layers units is equal to, let me tell you hp.choice, let me pass it like this. Okay, hp.choice, call it units 1, values is equal to 32, 64, 128, comma, come over to the bottom, activation is equal to ReLU. Okay, activation equals to ReLU. I'm going to come over here and I'm going to be done with it actually. Yeah. Okay. And you know what? Actually, let me model.add. Okay. Finally, write down the last layer called layers.dense because I have not taken the final layer. No. Layers.dense inside this 1 comma activation will be equal to sigmoid since we are performing something called as binary classification. Okay. And once you are done with this piece of code, I can just write down something called model.compile. And inside the compile part, my optimizer is always going to be equal to your Adam. I will come over here and I will say my loss. Since this is a binary classification, this is binary cross entropy, something that is very, very critical. And matrix is equal to ACC. When you see this piece of code, okay, sigmoid can handle up to 2, so we are writing 1. But if you had say 4 classes, then can you use something called sigmoid? Can sigmoid handle more than 2 classes, class labels? Which one will you use here? You will use softmax, and if you use softmax, then the number of nodes should be equal to the number of class labels. If it's binary class, use sigmoid. If it's more than 2 class, use softmax. Up to 2, more than 2. Why did we write it like this? The reason we wrote it like this is because in case if you want to build a complicated neural network, always write it layers dot, not input, not hidden, not output. Don't write it like that. Is how you write a basic neural network, but not your complicated ones. Is the idea absolutely clear? So for input layers, no need. Layers, yes, that is automatically yes. Can you see here this piece of the code automatically adds that? No need to take it as a separate method. If you want to pass learning rate here, we can also pass absolutely. Okay, so how do we class C Adam optimizer? Okay, Keras, so how do we add optimizer like Adam? We do it like this. Can you see Keras.optimizers dot? And inside this I can pass something called learning rate. Let's write it like this. From TensorFlow.Keras.optimizers import, what am I importing everyone? What am I going to import? I'm going to import something called Adam, okay, which is your Keras.optimizers. So I can even go ahead and directly import something called Adam here. Okay, ADAM Adam. Now what you can do now, you can pass the optimizer like this, Adam, and inside this you can pass learning rate is equal to 0.01. What we are going to do now is we're going to write down a code that performs hyperparameter optimization. How do we perform hyperparameter optimization? We perform it like this. Model is equal to models.sequential. Can I say this is an important step, everybody? I will perform models.sequential. Okay, my first hidden layer, my people model.add layers.dense, units is equal to units1. Let's say actually, let's take it like this. Layers units is equal to, let me tell you hp.choice, let me pass it like this. Okay, hp.choice, call it units1, values is equal to 32, 64, 128, comma, come over to the bottom, activation is equal to ReLU. Okay, activation equals to ReLU. I'm going to come over here and I'm going to be done with it actually. Yeah. Okay. And you know what? Actually, let me model.add. Okay. Finally, write down the last layer called layers.dense because I have not taken the final layer. No. Layers.dense inside this 1 comma activation will be equal to sigmoid since we are performing something called as binary classification. Okay. And once you are done with this piece of code, I can just write down something called model.compile. And inside the compile part, my optimizer is always going to be equal to your Adam. I will come over here and I will say my loss since this is a binary classification. This is binary cross entropy, something that is very, very critical. And matrix is equal to ACC. When you see this piece of code, okay, sigmoid can handle up to 2, so we are writing 1. But if you had say 4 classes, then can you use something called sigmoid? Can sigmoid handle more than 2 classes, class labels? Which one will you use here? You will use softmax, and if you use softmax, then the number of nodes should be equal to the number of class labels. If it's binary class, use sigmoid. If it's more than 2 class, use softmax. Up to 2, more than 2. Why did we write it like this? The reason we wrote it like this is because in case if you want to build a complicated neural network, always write it layers dot, not input, not hidden, not output. Don't write it like that. Is how you write a basic neural network, but not your complicated ones. Is the idea absolutely clear? So for input layers, no need. Layers, yes, that is automatically yes. Can you see here this piece of the code automatically adds that? No need to take it as a separate method. If you want to pass learning rate here, we can also pass absolutely. Okay, so how do we class C Adam optimizer? Okay, Keras, so how do we add optimizer like Adam? We do it like this. Can you see Keras.optimizers dot? And inside this I can pass something called learning rate. Let's write it like this. From TensorFlow.Keras.optimizers import, what am I importing everyone? What am I going to import? I'm going to import something called Adam, okay, which is your keras.optimizers. So I can even go ahead and directly import something called Adam here, okay, ADAM Adam. Now what you can do now, you can pass the optimizer like this, Adam, and inside this you can pass learning rate is equal to 0.01. What we are going to do now is we're going to write down a code that performs hyperparameter optimization. How do we perform hyperparameter optimization? We perform it like this. Model is equal to models.sequential. Can I say this is an important step, everybody? I will perform models.sequential. Okay, my first hidden layer, my people model.add layers.dense units is equal to units1. Let's say actually, let's take it like this. Layers units is equal to, let me tell you hp.choice. Let me pass it like this. Okay, hp.choice, call it units1, values is equal to 32, 64, 128, comma, come over to the bottom, activation is equal to ReLU. Okay, activation equals to ReLU. I'm going to come over here and I'm going to be done with it actually. Yeah, okay, and you know what? Actually, let me model.add, okay, finally write down the last layer called layers.dense because I have not taken the final.
I write down something called maximum trials, okay, is equal to, okay, maximum trials is equal to 5. My people in all random values that I have written here, in my neural network code of input neuron size 32, input neuron size 64, input as an hidden layer size 128, and the second layer 16 and 32, how many values will it pick up? How many random permutation and combination values will it pick up to run on? That answer or those answers, can I say it will pick up random 5, right? It will pick those random 5 values up and be done with it. Yes, once you save the tuning answer, you want to save all of that answer in a directory and you can just mention this directory as a logger, okay, in the hyperparameter tuning equals to none. Okay, we ran the default model, correct? Okay, the other model that we have built is the number one thing that we did, that I have chosen hidden layer number 1 and hidden layer number 2. Correct or not? In my model building, which is not the default model, I have given the option to to my neural network that either go with hidden layer number 1 or you can also create another hidden layer called hidden layer number 2. Correct? In hidden layer number 1, I have given the size called 32, 64 and 128. And here I have given maybe 32, maybe I have given 16. So how many different combinations will exist? 32 with 32 can exist. 32 with 16 can exist, 64 with 32 can exist, 64 with 16 can exist, 128 with 32 can exist, and 128 with 16 can exist. Can I say all of these are one existence? But the other existence is also that hidden layer 2 might not at all be taken. Only one hidden layer be taken. This is also one condition, right? Where the second hidden layer taken or the option of second hidden layer is also optional. I may not need it also, right? Out of these possible random values, I am randomly picking up 5. Even I don't know if second one becomes optional or not. I don't know yet, but I am picking up 5 random values. I hope you got the logic. When I say my maximum trial is equal to 5, I am not just deciding the values of the hidden layer. I am even choosing the hidden layer also as an option. Maximum trial is equal to 5. It will only allow 5 trials. Only 5 trials. Not more, not lesser, exactly 5 trials. Directly 5 trials. Okay, if I would have taken hidden layer number 1, hidden layer number 2 and hidden layer number 3, have I told the machine learning or the neural network model exactly how many hidden layers I want? Okay, if I do this, then does it become easy for me to decide the hidden layer number 1 I want to try for size 32, 16, 64 and 128? In hidden layer number 2, I want to try for 68. In hidden layer number 3, I want to try for 8, 4 and 16. How many combinations exist that my neural network can be tried for these many combinations? This is 4, this is 2, this is 3. What is 4 multiplied by 2 multiplied by 3? What is the answer? Can I say different 24 values can be checked or 24 different values need to be checked? Do you guys agree? But why? Because I have said very clearly that I know for a fact that hyperparameter tuning will happen exactly on 3 layers. Correct? Yes, if I tell you that I don't even know that even if I want 3 layers or are only 2 layers important, only one hidden layer is important or all 3 are important. Now does that include hyperparameter optimization on hidden layers selecting the right value, including choosing whether only 2 hidden layers should be taken or 1 or 3? Have we done both the checks or one check?
Have we done only the checks of the numbers, or are we also performing checks on the layers, on how many layers do we need? We are performing both, right? That acknowledgement I wanted to understand. We are not just simply telling you that I want 3 hidden layers and you just strictly do it for 3 hidden layers. No, right? Okay, and isn't it awesome to run the Keras tuner in such a way that it tells us an idea what combination it chose to run so that we know exactly what is the answer. Of course, we also will run that. Don't worry, it's handled by Keras directly. But what's more important is this particular important keyword called early stopping, because this will definitely show up in your interviews. Anybody who's going to be taking your interview, forget generative AI, he or she, okay, whoever's conducting your interview is guaranteed going to ask you this question: what is early stopping? Okay, and why is early stopping very, very important in deep learning? You must have learned 100 other things in deep learning, but early stopping is one of the most important thing. Allow me to explain this. Right here saves you money and time. Okay, let me just say it saves resources. Okay, resources. Now, why are saving resources important? Let me explain. Everyone, when you run a deep learning model, okay, have you encountered one small point? Have you observed one thing? You all run deep learning on a dataset size which is literally very, very small. Maybe 1 lakh, 2 lakh, maybe 3 lakh is the maximum data that we have dealt with so far. Yeah, the dataset size isn't that large, right? 1 lakh, 2 lakh is small. It's nothing. It's a small dataset size, right? Okay. And the second thing is you try multiple different combinations, permutations, and it takes a lot of time, right? Trying everything is going to take a little bit of time. Now, the problem in this is, suppose you have built a deep learning model with 1 input layer, 1 hidden layer, and 1 output layer, keeping your neural network very, very simple, okay? And inside this neural network, you give the value of epoch, okay, is equal to 150. Your model's performance is looking like this. Okay, your model's looking like this. Your neural network x-axis is the epoch, y-axis is the accuracy. Okay, 1, 2, 3, 4, 5, and 6. Your model's accuracy went like this, like this, like this, like this, like this, and it became completely stagnant. Now everyone, listen to me. Okay, listen to me very carefully. Can I say model had no improvement or your model did not show any improvement right after this? After this, your model pretty much became stagnant, right? Your model had no improvement at all. After epoch number 170, your model after 150, or I have epoch 150, right? So after, let's say 45, your model's improvement was not observed, right? So after 45th epoch, my model literally showed no improvement. It became stagnant, or you can call it saturated. Okay, it became saturated. There was no learning there. Lovely, my people. Wouldn't it be amazing to tell my machine learning model that the time that it took for me to run this much extra epoch, somehow my deep learning model will just stop my model if there is no improvement over the period of time? My deep learning model should stop, saving me time and energy. Because if I don't do this and if I still run for 150 epoch, wouldn't my neural network model take time, but the loss is not decreasing, accuracy is not increasing, they are pretty much the same number. Don't you think it's important where my neural network should have stopped or would have stopped? Saves a lot of time when you are dealing with a large data. You are performing lots and lots of optimization. You want to try multiple different things. You want to train your model under those conditions. This is going to help a lot. This, my people, is what we call as early stopping. Now in English, what do you mean by early stopping? Are you literally stopping early? You are not letting the whole code go through the entire epoch cycle, but you are breaking the whole flow in between. Correct? You are breaking the whole flow in between. Correct? That's what we are doing, everyone, in early stopping. No, we have a very important keyword, and the name of the keyword is called patience. What do we call this? What do we call this? Patience. Even your neural networks need patience. You are only a human being. Even your neural networks require patience. You are just a human being. So anybody in the class who feels impatient, you should always take inspiration from your neural networks right now. What is patience? Okay, everyone, this patience is like a window. Okay, it's like a window. Sir, what do you mean by window? See everyone, in epoch number 1, epoch number 2, epoch number 3, epoch number 4, epoch number 5, epoch number 6, epoch number 7, epoch number 8, and epoch number 9. Okay, your loss or your validation loss, okay, in these epochs were like this. Let me explain. Okay, it was looking like this. 0.17, 0.36, 0.47, 0.47, 0.77, 0.16, 0.38, 0.382, 0.3816. Tell me which value to which value is not showing considerable dip in my loss. Which epoch to which epoch is it showing no considerable improvement in my loss or any decrease in my loss? Can I take 6 to 9? Okay, my people, patience is equal to 3 or 4 or whatever number n you choose means you are going to tell your neural network that look, if 3 values consecutively are not showing any improvement, I'm going to stop my model right there. Did you understand the concept of patience? If 3 values consecutively next to each other are not showing any improvement, I'm going to stop the model. I'm going to say that look, according to my neural network, since the last 3 model, my model has not performed anything great, so I'm going to stop the model. So no improvement means stop the model. So did you understand that every early stopping that you implement needs the value of patience? Yeah. And what are you monitoring when you perform early stopping? Remember, you monitor validation loss, not validation accuracy. Understood? Understood. It's the loss that you monitor. So tell me, if I come over here, write early stopping, and if I say in early stopping, TensorFlow.all callbacks, okay, callbacks dot early stopping, can you see there is already a method called early stopping? Okay, what do we want to monitor, everyone? Do we want to monitor validation loss? Am I mentioning that my monitor is validation loss? And what is my patience value? Right, PATIENCE. Validation accuracy is checking for model's improvement. Losses are to check your model's improvement as your model's function to check specifically things like validation accuracy. So your early stopping, why? Because if your model's losses are not decreasing over a period of time, what does that tell you? What does that give you an idea about? Your validation accuracy is not going to be the right approach for checking something called as, okay, why is my model not performing good? That is not, how do I say this, not a very good and a very approachable model. Because what happens is, every time you monitor something versus optimize something, right, your validation accuracy is the metric at the time of training and tuning, and that's what you're going to use, right? But to optimize something, what should you do? Well, both are important. Validation accuracy is important. Validation. So if I say top 3 value of tuner.get best hyperparameter number of trials equals to 3, it is actually supposed to return, but in our case, it is not going to return. Okay, if I remove this 0 also, now see, if I remove this 0 and if I run this, now it says list object has no attribute values. Right, so what do? If I want to remove this and rewrite the code, how would I do? Can I say it like this? For I, hyperparameter of my choice and enumerate it. Right? That's the most fastest way of doing it. And let's say I say best underscore hyperparameter in my model, right? And if I go ahead and print F quote, maybe rewrite it in a different way. That for the rank of that particular variable, I got for that I plus 1 index. Okay, so let's say it is for that I plus 1 index that I'm trying to find out. I have what? My best hyperparameter. Right? Or whatever my hyperparameter value is. Let me say hp.values. Right? If I run this, 1 and 2, let's see if I get for 3. Give me 1 second. Let me cut this out. Wait, let me copy this, put it in the top, paste it here, and let's remove this. We don't need it. Number of trials equals to 1. Give it a 0, and then give it a uncomment here. And let's see what is the hyperparameter. I got 128 and this. Okay, now I will remove this. And for that, hyperparameter number of trials equals to 3. Okay, so now when I performed rank operation, which is for index by index operation, first one is this, second one is this, and third one is this. So maybe you can loop it through like this, directly asking for the values, or you can just run it through this and give the best trial. So maximum or number of trials is only going to tell you that which trial tells you which answer is it going to give you relevantly. Okay, that's the only difference on this. Got it? Oh, by the way, what is this second layer equals to false but unit 2 is equal to 32? What does it mean? Have you observed the answer? Why would it give you that answer? If you look at my code, what default value comes up at the top? 32 and 16. Yes. What do you mean by false? Does it mean it ran? False represents not, it did not. Okay, so you can ignore this. Don't worry about it. Okay, it's been skipped. Okay, now everybody, we saved our model. Didn't save the model yet. We just ran the model and now we want to save it because I want to give my model to somebody else to run and make the predictions to see how my predictions work. So if I say best underscore model, let's say I want to save it. Dot save, inside this, if I write down things like best churn model dot h5 h5. What is this going to do? What is this line of code going to do for me? What's the goal behind it? Is it going to save a model in my local system with that name? If I run this, yeah, okay. More interesting is this warning that you get. I'm going to copy this warning and I'm going to show you what it means. Okay, copy and paste. Everything has an intention behind it and you gotta understand the intention, my people. That's very, very important. Okay, everyone have a look at the warning. What does it say? You are saving your model as an HTF file via model.save. Okay, the file format is considered legacy. What do you mean by legacy, everyone? What do you mean by legacy? Old? Is that something that comes to your mind? Yeah, your brain automatically goes into the, oh, legacy, right? Yeah. Now, is legacy good or legacy bad? Tell me this. My question to you is very, straightforward. Legacy is like old traditional model. My people, everything new, does it have to be good and everything old, does it necessarily has to be bad? Is this something that is like a generic statement? Everything new has to be great, everything old has to be bad? I'll give you a simple example. When I was a child, my father had bought a car called Ambassador. I'm sure you guys know what that car looks like, right? It was like a truck on a wheel, right? It was such a heavy car. It was just crazy, right? And then I eventually, bought myself a new car. And I feel better now. We shifted from, this to my newer version of car. Now my question to you is this: does my new car necessarily work for me in every single way? My answer, let me tell you with a lot of experience, is absolutely no. Terrible, right? But when my old car was built tough, ran for a longer kilometers, run well, now why am I mentioning cars to you, right? The reason why I'm mentioning the cars to you right now is because just because you get a warning that the model or this particular variable is legacy, what I want you to understand from this is they have a newer version of serialization technique which is available. But number one, can you still save it in the legacy file? Can you still save it in the H5 file? Yes. The answer is, first of all, yes, you can, no doubt about it. But, sir, what is H5, right? See guys, HDF5 is hierarchical data format. Okay, this is also a serialization, approach where if I show you how does it look like, okay, give me 1 second, HDF5. And click on this. See guys, this is hierarchical data format. Version 5 is a file format, data model and library for storing and managing large complex data sets in a hierarchical structure. Now you must be wondering, what is hierarchical structure like? What is this hierarchy, right? See my people, I'm sure you guys know that whenever you save some file, like pickle file, HDF5 also is built in such a way that you can save your machine learning model in this format. Why is HDF5 important? Why not pickle? First of all, there is no comparison there. If you want to use a pickle file, go ahead and use a pickle file. If I wanted to show you how to do HDF5 file, I showed you H55. In the future, I will also show you a format called Keras. I will also show you in the future a format which called as a torch pickle. I'm also going to show you something called brain float save or BFS. Meaning, am I giving you guys options for you to decide which works best for you? Because which file and how you save it depends on your goal. I am simply showing you the different variants that are available in the industry in which you can save the file. In the initial model, did I save everything as a pickle file? Yes, I did. Am I saving the file as H5 now? Yes, I am. In maybe some other examples, I might show you Keras. Maybe I show you the torch file. Maybe I show you the brain float save. Or maybe tensors. Point is, you can choose any. But sir, what is the difference, right, among all of them? I want you to take this up as an exercise for yourself, that why should you save something in pickle file, why should you save something in H5 file, and why should you save something in test file. And whatever you find, I want you to post that. I hope you got the idea. What you're going to do is you're going to create engaging content on LinkedIn. Create good network. It's going to give an advantage to you. Second point, you will start developing the habit of research for yourself. And don't worry about your aura, okay? Your negative aura and positive. I don't understand this Gen Z slangs, but let me tell you something. If you make a mistake, okay, you know for a fact that you have done your research wrong. If you do your research right, you'll never going to be wrong. And never be scared of making a mistake. If you've made a mistake, somebody will come to your post and I will say, especially a person like me, and I'll come and I'll say that, hey, I think that's not exactly correct. Maybe fix it. You can go ahead and edit it, change it, re-upload it, or maybe edit it. That's okay, that's up to you. But build this habit so that everyone on the LinkedIn knows that you have been uploading content related to machine learning since a long time. What's the harm? I mean, what's the worst that could happen? Nobody's gonna, take you to a police station and say, no, you got the answer for H5 wrong, right? Got the logic? Are you going to check the validation? Are you going to validate which one is better, which is not better? Get an understanding and then upload it on your LinkedIn. Post it. Start posting. Start giving people an understanding and knowledge. If you guys want to create your reel, it's up to you. You want to create a LinkedIn post, it's up to you. You want to send it to your friends, no problem, it's up to you. But build it. What did we do so far? Did I save my file in a model H5 file? If I come over here, is my best churn model.h5 saved? Best churn model.h5, is it saved? It is saved. My people, do you also need to save one other thing? What is that one other thing? Do you remember you have something called selected features? From all the list of features, you have some selected features that you were able to print, right? You were able to get the idea from the model, know that these are the selected features. Do you want to rerun the model once again, recursive feature elimination once again to save it? No, right? You don't want to run the model again, no? So you can save recursive feature elimination results also, right? With open, okay, can I say selected features.pickle? Am I taking the recursive feature part or my selected features as pickle? Write down as write binary as f or as a file format f, which is your variable with the object. Selected features is equal to pickle dot load. I'm going to write down the variable f. Okay, pickle dot load f. Am I loading the selected features also? And with the selected features, am I also going to load what else am I going to load? Am I also going to load after the selected features dot load? I'm going to say with open. In fact, I can just copy the whole thing, paste it here. Go back, and this time, what do I want to load? My selected features.pickle file. Copy, paste, and what do I do with this? This is my selected features. Copy this, and paste it here. What have I done, everyone? Have I loaded my model, my scalar, and my selected features? All three of them are loaded and good to go. Correct? WB or RB. Understand, read binary is to read the file, write binary is to write the file. Understood? The difference between W and R is to write something and to read something. To save something, always do write. To read something, always do R. Understood? You don't need to write, no, it's already written. You don't need to write anything. You just need to save it. You just need to get the answer. Now what do we do? Is this loaded? Okay, once it is loaded, do we return everything? We return the model, we return the scalar, and we return the selected features. Copy and paste and run this. Can I say my define load model components function is done, good to go, packed with all the important information I need, right? Okay, now I'm going to say predict churn. I want to predict whether my variable or my customers will churn or not. But am I not passing multiple different arguments? So I'm just going to write something called args. I'm passing multiple information about the customer, and I just need to go to do that, right? Say model dot scalar. Okay, scalar is equal to or model dot scalar. Let's also load selected features is equal to load model component. Since I have taken all three, let me just call them right here. What am I going to do? I'm going to take my input data is equal to, I'm going to convert that into data frame so that all of you can see, and I'm going to inside this pass something called args, which is the values inside my model, okay, and the columns that I'm going to include